you can choose the laptop.
I bring my laptop.
Yeah, can also can use that as got the software inside.
Okay.
I mean, got installed.
If install for guide me as well.
Yeah, can sure. So we will use this laptop first, lah.
This one?
Because you will be learning Omron and Mitsubishi, right?
Yes.
TVS say you will start with Omron first. Mitsubishi, GX Works 2 or GX Works 3? Not sure.
I'm not sure which version is.
Mitsubishi is right behind your tag. That's one. Which PLC? This is the GX Works 3 newer model one. This one is the older model one. Which PLC? Because both also using different software.
Yeah,
this one using GX Works 2.
Okay.
This one using GX Works 3, which is the new.
GS is still Omron?
Omron is CX program.
CS.
Yeah. GX Works 2 is the older version that we used to use. Then last year we moved to GX Works 3 already, which is a newer model. So it depends which one you want to choose. I have manual for GX Works 2 and GX Works 3 also.
It's a huge difference.
Yeah. It's when it comes to that firmware version, it's more upgraded. Like GX Works 3 is way better really. But the problem with this PLC is this one only can be used for the older software. GX Works 2. But when you install GX Works 3 software, they will give you together GX Works 2 and GX Developer as well.
Then it's good. Then better this one.
This
because
one,
in futures, anything that we still can read on the old one, right?
Yeah.
Anything MMS also, but can be is workable for the old versions, right?
Yeah, can also. Yeah. Soft copy of the manual should be in the laptop. Then later you get to
You change the name?
there you go. I mean, it's Yoki's.
Yoki's.
Yeah.
I want to message you, right? Yoki's. Yeah.
Message me.
Last time.
Last time.
You passed to the.
Yeah, then I passed to my trainer.
Yeah.
But he will prepare all the quotation and he will just
That's kind of a lot of questions. That's a lot of questions, much in my mind.
It's okay, anyway. Like I said, my name is Yoki Swaran. I'm the training organizer, manager.
Everything.
Manager, I do the marketing also. Most of the time I focus on digital marketing. You gotta be kidding me. This is your laptop. I have the same model right over there.
Yeah, bulky one.
My boss used to use this model.
Bulky
But powerful.
Yeah, bulky is
very powerful. But only thing here is the power supply also heavy, the laptop also heavy.
Yeah, and I bring my light one. That's why I got two laptops here. One light one, I'm not sure whether can be used on the programs or not. So I just bring it along. So, but in terms of working wise, overall, we'll be using this.
Okay, anyway, so before I give a quick introduction, because this was a way, let me just grab your name, IC and email address so I can prepare the attendance certificate and everything. Well, I think, I will prepare two types of certificate, basically at once, for Omron and Mitsubishi. So just your name based on IC number and email address. Because I will, at the end of the training, I will give you hard copy, I will give you on the last day of the training, and the soft copy I will email to you. Name, IC and email address.
You're also a programmer as well?
Nowadays I'm more focused on marketing and management. I don't know time really. Last time I used to work on the Magic, but my background is more to IT. Even that your trainer's background is mechanical and he has basic knowledge. I mean, he has advanced knowledge really in electrical, and then he joined us in 2015. He joined us in 2015 and he was trained by my boss, Mr. Sundaresan. His introduction is right over there. He's now retired already.
Oh yeah?
Yeah, my boss retired due to his health condition. Okay, so his background, he was an ex-army technician. Served
Army
under
technician.
Army technician, served under QDM. Then after he did not complete his service, but at that time he's now 75. He's now 75, and at that time Singapore was booming, so he moved here. He's from Kedah actually. Then he moved here and he looked for a job in Singapore, and then he did his because before that he graduated from Royal Australian Air Force as an instrumentation engineer. Then after that he moved here. Then he did his industrial automation diploma in Nanyang Poly. Then he became passionate with PLC. The first PLC he touched one was the older model DOS-based S5 PLC. Still got some company running with that PLC. Still got later maybe we can show it to you. I think we have one. Yeah, this one. This is an older model. This one not using Windows. This one completely using DOS-based program. This is 1960s, 1970s. Still got some company running.
Before my time.
Before my time. So, and he became passionate with PLC. Then the first PLC he touched was Siemens. Then after that he slowly moved to learning on Allen Bradley, then Mitsubishi, Omron. Then the less demanding one like Siemens, Schneider, G. Fanuc.
Less demanding Kian. And now less skill.
Yeah, Siemens is now growing out of nowhere. I shouldn't be saying less demanding. If it was 3 years ago, yeah, it was less demanding. Because most of the time, the very demanding one is always been Siemens.
Because Kian one is because they want to sell their own mission. That's why they attach to their own PLC. So together one allows up to me.
Yeah, correct. So then after that, in 2010 like that, 2010 or 2008 if I'm not mistaken, like that he collaborated with his German partner and they opened up sales automation services in Singapore. And yeah, at the meantime he did gain his experience from few companies. I think he worked around 50 to 60 plus companies in the past, and then did few projects. And then he opened up gas automation services Singapore, mainly focused on project and services. Then in 2012 he opened up this company here, and here we mainly focus on training. And yeah, we did start focusing on services. Services around here, 100 kilometer radius we focus. But if you want to, where are you from? KL. If you want us to come to KL, there will be charges on traveling and everything, which might, look higher. So we only focus 100 kilometer radius over here. Project we can do worldwide. Normally most of the time we used to focus on any tender under UTM, given by UTM or UTHM, or we used to focus on ASRS projects.
Yeah, this one is focus on office.
Yeah, focus on office. Okay, so since 2012 until now, we have trained more than 3,000 plus participants. I think almost hitting 4K every. Not only Malaysia, I don't know how foreigners find us. Yeah, also our client from Singapore, our first client from Batam, and we used to get clients from Libya, Turkey, China, I think twice, India many times. And last year, for the first time, we had one Mansari also from Scotland. He was doing some project in Singapore, and he found us and he said, "Can I join?" Yeah, come. Then he come and joined us as well for 5 days training in Siemens. So yeah, so then Tivian he joined us in 2015. He's a mechanical background. He's from Onsite Poly.
The training later.
The training later. He's from Onsite Poly. He joined us. Then my boss completely trained him, and now he took over my boss place. He's a senior trainer. So yeah, this training will be 8 days. Timing will be 9 to 5, 1-to-1 training. Water bottle right over there. Switch if you need one, you can grab it. If you need coffee, 3 more coffee, tea. So what is black coffee packet? All I prepared over there already, including glass. Water also like that.
Cake and dessert.
Desserts, yeah, biscuit. Cookies and biscuits are there. Yeah, you can grab it as well. Yeah. Dessert, what you want? Cake. Because restaurant all walking distance here. Yeah.
Stay in this.
Leverage. Yeah, just right in front. Mama restaurant. There are a few Chinese restaurants there.
Nearer there.
Mm.
But I found there's a lot of, I don't know what is it, a lot of file. That's why I got confused about this. I actually, in practical, I never really work on PLC and then with the HMI.
Okay.
I know my project side, I always do that.
Mm-hmm.
So I want to get some learning. Because my background is engineering, electronic engineering.
Electrical. Okay.
Electronic. So we usually in it, of course, class we also have this kind of PLC training, so PLC learning. But that's one is only for some
Very
yeah.
basic. Very basic.
So that's why now I'm getting more into these kind of things. So I want to have some idea how it's really work between set password and so on. So
Can show it to you.
because too many files quite confused on me.
Mm-hmm.
When you back up a file, how you open a file, what software to open a file.
Mm-hmm.
But just now you mentioned the GS Word 3, but now they, is it GS Word 2 is the same software?
GS Works 2 is the older one. I think this laptop, he didn't install GS Works 3. Then later on, that's what the problem for the issue.
Yeah, can send me the, then get one.
GS Works 2, yeah. This one, GS Works 2.
I'm not sure how I
yeah,
install
yes.
correctly or not. I'm not sure installing correctly because
Wait.
I just simply call install. No, I'm not sure it's installed correctly. How is it?
This is version 1. Just to make sure we run as administrator.
Because I saw with me that they have anything say you need to install this, you need to install that. I think no.
Maybe the communication driver you haven't installed yet. Later let you check. No guys, you know. Coming. I need to do it. Maybe start with the today, Friday. Coming here. Oh, message in here, okay. Oh, okay. I'll be here in 10 minutes time.
No.
Yeah, sorry for that.
What is the password here?
Okay. Username and password is right over there.
Oh, okay.
Yeah.
No issue. how's the JB life?
I've been here for 35 years already.
Good.
Okay.
Moving already in JB.
Yeah, most of the project in SCADA and all the cloud computing project that is going on, investing by Microsoft. So it's quite getting okay, but I hope it doesn't repeat the same cycle again. Just like the previous project that happened in close to the Singapore border over there. Now it's completely abandoned. That what that I forgot really. It's a garden. I think it's around $15 billion project. I think it's more than that. They turned the entire island into artificial island and built an apartment there. What garden something?
Yes.
I forgot the name really. Yeah. The last I went there, wow, it's still very empty.
Now okay already, right?
Now, yeah, there's just few people buying some properties there, and they turned that into a duty-free zone.
Yeah, they turn that into a job. That's the way that they try to attract. I think that's the reason why also.
Yeah, that's the reason why most people try to go there.
To please
Yeah, but still, the thing was still very empty. Still look like a ghost town. Still. Because the property, I mean, the entire place is so big, and some of their property price for each room can come close to 600 to 700K. I don't think most of the Jordanians want to buy that place also. 600 to 700K, they will try to look for a landed house instead of buying an apartment.
True. They try to attract those investors instead of local. Like basically, I also some people also say, oh, you can. Let's say for example, you got money to around 600 to 800,000. Why you want to buy a condo in Singapore? You can buy the land. Why you want to choose that?
Yeah, that's true.
Condo. And some more outskirts also. So there's too many condo now, right? Right. The condo is good on the city, but sometimes the condo is built on the outskirts. I wondered why they want to buy here. Some condo is
Majority of buy over there are mostly foreigners. Mostly foreigners. Just for investment reason they buy it or for quick getaway. If they want to come here for holiday or something like that, yeah. So yeah, son, trainer just took his son to clinic. Son got a two-day license. So you'll be here in 15 minutes time. Once a certain situation cannot stop like what to do. So your company do machine projects or?
We do for machine project, and most likely I'm more interested on the training side, training about Hakko, all those kind of stuff.
Cobalt arm and everything. Okay.
Yeah, Hakko arms and so on. So that's why sometimes we have some project in here on the Omron side, or PLC side.
Okay.
So we do the project for ASI as well, on the manufacturing system, the press line. Using the robot control. We are using Mitsubishi.
Okay.
And some Hitachi aircon as well. We are using PLC. That's why I mentioned. Now they are quite smart, so they want to push their own product PLC for as a one package. some of the machine project also for the vision inspections.
That should be okay.
But for me, really fundamental because of this.
Okay, that's why when I come to PLC, just basic.
Yeah. That's why I need to know how the project is there. At least when I look at the program, I know what is the issue and how to start from the beginning. How you guys when want to create a program, what things you need to prepare. I heard a lot of people say they need to prepare on those kind of what IO mapping. No, besides IO mapping, they need some IO mapping, right?
Which one?
They need before they want to create program. They need your mapping, IO mapping.
Yeah, input and output mapping. Okay.
That's a
Flowchart, it's like a flowchart.
Flowchart. And then there's a lot of things to consider.
Yes.
So that's why.
That one all given he will go through and teach. Because most of the time he will first start with the introduction and understanding of the company system and everything.
Definitely.
Then after that start creating straightaway jump into start creating a project.
Yeah.
Open up a ladder logic program. Do some simple project first. And most of the training he always goes on the project side. We just come up with smaller project and go bigger project. So most of the time you will be like practicing, keep on practicing, and that's how you learn.
Good. Yeah, because that's what I need to know. But I did have a few times of PLC training before, but mostly just on the theoretical and things. And at the end, I did not get how it's actually working with the machine. So that's why.
They will have fancy training kits and everything.
Yeah. That's why when I first when I look at your training, I do consider a few things, but you're more into practical as well. That's why there's something.
When we come to practical, we keep it as simple as possible because most of the participants who comes here, they always looking for more information on certain programs.
Yes.
And then when it comes to servo motors, programming and all those stuff.
Yeah, that's right.
So when it comes to theory, we just touch a little bit, then after that we jump straight to practical.
Yeah, I prefer that now because I'm not that level already. To say that one is just English. No, I need more in terms of practical side.
Even we used to get clients from UTM, from UTHM, from Uni Utama. It's not the students who comes here. It's the lecturers. Because one thing can say is when it comes to theory, they are very strong. They are solid. Theory, they are solid. Practical is out.
Yes.
So they bought, I think they invested around 2 to 3 million ringgit worth of training kits. They bought everything. They set up an entire classroom over there. And then after that they don't know what to do with it.
Yeah.
And then they end up starting to look for people like us. They called us. We have bought this training kit, or can you teach us how to operate with it, and maybe we can prepare a manual for that.
That's how yeah, we know exactly this program over in terms of how to operation.
Yeah.
Practical, because sometimes I need to support on the site as well. When we have a staff limitation as well. So I need to get into this set by myself as well in terms of anything support. If there's the staff, come and go.
So when it comes to basic onboard robotic arms, right? Correct me if I'm wrong. Robotic arms, how much is the cost will be?
Depends on the kgs. Now the price can be, I can say now the price is quite competitive already.
Okay.
Because the market.
For example, like me, I just want to buy it for training purpose.
3, 4, 5. The minimum is 3K.
3K.
No, I'm so sorry. 3K payload. So the price would be around 30 or 1,000. 30 or 1. Very good. So you do for the component as well?
No, we haven't come up with a cost structure to teach on robotic arms and everything, but we mainly focus on basic electrical courses and PLC HMI and SCADA courses.
I think you focus where you are.
Yeah, we mostly focus on the demanding stuff. We tried like instrumentation courses, we tried that were not much demanding. So we just focus on PLC most of the time. Even electrical basic fundamental in electrical electronic training also. That one we offer that for 5 days. Once a year only one participant will come and request.
Yes.
But most of the time it's always PLC. Because they can come to basic electrical also, the client who request also they are not engineering background, but they want to jump into engineering, they want to jump into this field and they want to learn PLC. Most of them are either IT or no, they are from business management or something, running an engineering company like me. So they will come and learn. Just the robot arm, including all the communication and everything, including the software also, or just the complete set with your software and everything. Want to have a coffee with you and have it over?
Okay.
Yeah. And I mean, you already settled full payment, but still got balance, right?
Yes. Yeah.
Balance is the 50%.
Yes. 50.
No, I need to be able to borrow you this
Yes.
time.
Tomorrow.
Take it. Okay, this is Mr. Divyan, your trainer. So, yeah.
Yeah, sorry, yeah. Go to clinic. Take care.
Oh, for you today?
Yeah.
Oh, okay. Why is that?
I don't know why. I need to go to
suite now.
Sweet. Normally we don't take the sweet also.
Yeah, I need to go to just now to went to normal clinic.
Oh, okay.
Just now the doctor said it's a growth.
Oh. So you okay? Huh?
Yeah.
Oh, I think we need just something. Okay, I'll just pass it to you.
Right.
Start the training. Okay.
Thank you.
Sorry about that. Sorry about that.
No.
And
Understood.
and extend the 5:30 lah.
Yeah. I will be here at 6 also can.
Okay. So Mr. Brian, right? Mr. Brian, right?
Yeah, Brian.
Where you from?
Okay.
Yeah.
Yeah.
So where you live here?
I stay here.
The leverage.
Leverage.
For 8 days, huh?
Yes. Please.
Why don't you take homestay or something? Didn't get homestay? Didn't check.
Actually, homestay also not
Cheap.
cheap also.
Oh,
So that's why
hotel is better.
hotel still better.
Yeah.
Not cheap then
Because I know there is
homestay here.
there's a studio apartment.
Oh yeah.
Yeah, this building.
Oh okay.
If only last time I have few participants.
Oh. Not finished.
Yeah. So much.
That time to search.
Yeah. So you're okay, what you're doing?
Myself.
Yeah.
Of course, I'm more on the automation side also.
Okay.
I'm more into the management side.
Or management
So
side.
project side, project team lah. So, but I also need to back up some time because lack of manpower. So in terms of PLC side, I need to know how it's operated. I have an engineering background.
Okay.
So electronics, I'm master in electronics.
Electronics, okay.
So a master in degree. So I learned PLC before, but not in terms of practical.
Theory lah.
Theory is basic, but now still need to refresh back how is actually operation. I really need to touch on the machine,
Yeah.
touch on HMI, how is the handling of both,
Okay.
and communications. And I saw they found a lot of file, but I don't know using which how to open the software into the program, using what software to open up and so on.
Oh, okay.
So that's why I need some basic knowledge from your side.
Okay.
And see how to operate on those things so that I can look at their data and see what actually problem with the manufacturer. So otherwise I will blur my sotong because I look at file how which software to open and so on.
Software, yeah.
And then how to operate and how change and then change the password and how to communicate with the IO link and so on, and how to get some data on how the communication link, whether and how to check whether which signal and blah blah blah. I think you are more expert. So no, you really are expert. So that's what I want to get to the practical now.
Okay, sure. So so your company doing projects,
Yes, project.
or you working in a manufacturing company?
Project and myself is more fully. Myself is really more focused on the serving robot, cleaning robot,
Okay.
cardboard,
Okay.
and those products.
Okay.
Those kind of robot we handle lah.
Oh,
But in
robots
terms of-
with the PLC also lah.
Yeah.
The
Robot. That's why I need to PLC not some cobot yes link with PLC and so on. That's why also we do have a big building our own machine, built for the client silicon vision inspection.
Okay.
So they need they need a PLC control as well. So
Mm.
I want to see the data and so on. Some I need to support as well. So before that I don't need because my staff getting issue. So
Okay.
I need to back up my
Support
client.
on Yeah.
support.
Okay.
In terms of what issue, so anything next time I can do a troubleshoot myself.
Yes, yes,
Instead of
yes.
depends on the staff lah.
Okay, okay, sure, sure. Understand. So you okay. That means you supply machines lah.
Yeah.
Okay,
Yeah.
okay. Alright.
So
That's your laptop, is it?
that's the two laptop. One is more comprehensive. One is more light version.
Yeah.
So I'm not sure whether this one. If I bring this one, I'm not sure whether it's support.
Okay.
And this
Yeah, support. That one we support. This one is what laptop?
this one is HP.
HP.
Yeah.
Oh, okay. That one HP.
S1.
Okay, okay. Can. Omron is not an issue. What Windows? Running on Windows, right?
Yes, both running window.
Yeah. Omron and Mitsubishi not the issue.
Omron is
When you come in installing on Windows, it's not an issue. Omron and Mitsubishi. Normally we have an issue with Siemens, LWD, sometimes if not compatible, then we give error now and then.
That's why in commerce what we are doing for clients is more into Omron and Mitsubishi. Whether other product, other PLC, we try to forget it first. But now focus on these two is happy enough.
Yeah. Because for robotic, normally like I've seen before, for robotic mostly they use like Mitsubishi, Omron, Siemens, Panasonic, the Japanese PLCs. Okay, because Japanese PLCs are more on because they use a lot in manufacturing industries, manufacturing, semicon, okay, all that. Because mostly are like standalone machines, right? Like Siemens and LWD mostly they use in like oil and gas, power plants, chemical industry, food industries, on that. So need a lot of like analog sensors, pressure, pressure sensors, temperature sensors, all that lah. So for that mostly they use Siemens. If the PLC need to handle with just simple input outputs, the sensors, normal proximity sensors, all that they use a lot of Omron and Mitsubishi. But in Malaysia, these four are famous, if you ask me. Siemens, LWD, Mitsubishi, Omron. Based on our training requests and also whenever I go troubleshoot with company as well, same thing.
But in terms of programming language, it's the same, right?
All PLC same. That's why I can do like 7 type of PLC. Training, troubleshooting, any PLC I can do. Make sure I can get the software. If I able to download the software, install it in my laptop, then I can troubleshoot. If I cannot, install it in my laptop, then I cannot troubleshoot. Because the most important, like you said, the software. You need to know what software it's using, right?
Yes.
Okay.
That's why the Omron, the one software I installed, the GS
Install.
I haven't, and Hakko I haven't because I don't know because
Okay, Hakko no need, no problem.
Hakko no need.
Hakko no need because it's depend on what type of HMI you want to use. You can use Hakko, you can use the Wintech, you can use the Omron, there's a lot.
But this one, but just now I heard your
because this one I give to you, right? Okay.
Your mentions, he said got a new PLC GS3.
Yeah.
So do you have that version?
Software.
Yeah.
Yeah,
Because
I
after
can-
I learned the new one is instead of old one.
Yeah, can. Both are same only.
Yeah.
Both are same, but the new one has some new features lah, no problem.
Okay, good. So in future we can use the I can use the
This one very user friendly also.
Okay.
So we can use this lah, no problem. So we can use this
Yeah.
and this. Even Omron also they have new.
Oh yeah.
Yeah.
The new one.
New one. So Omron new model.
Okay.
It's not old model lah. The one I give it to you the software, right? The
Yeah.
CX program.
Yeah.
Okay.
That one is
That one
this
is for these models lah. All these models are using. Omron new model is this one. It's using Sysmax Studio.
If let's say this 6-Max Studio can support this one?
No, cannot.
Cannot.
Totally different way of programming.
Huh. So the common one will be this one first one.
Yeah, of course.
Have to
Because
learn.
normally, mostly the companies still using this lah. This one, very less. Even I get training requests, like 1 year only one training for that. I mean, still the company not, prefer this because they already have the machines. Even still some company when they buy a new machine, they have this one because they already have a CP2E ready, the new model. So still, this one still growing lah, this PLC.
Okay. Okay, maybe.
But if you learn this one, you can easily learn Siemens. Yeah, because the way of programming everything similar to Siemens.
So you recommend to using the old one first, lah?
Yeah, this one first can.
Okay.
This way you can learn this first. Then first got 8 days, right? We have, if let's say I have one day, I can show this one also.
Okay, cool.
No problem.
Alright.
Okay, so your laptop already have a Mitsubishi. I mean, Omron is it, right?
Yeah.
So you Omron you install that, Mitsubishi you install that. Is it
Both also installed.
Oh, you both also install.
Yeah.
Omron also install, you Mitsubishi also install.
Yeah. No, not yet. Mitsubishi, not yet.
Mitsubishi. Here only Omron.
Mitsubishi, actually, I'm not sure whether I installed correctly. Maybe you can show me the step how to install this one. Just direct. Yeah. Because why I found it complicated because
Okay, now wait. First, both is your laptop.
yeah.
You use both, not company one. Both
No, yeah.
Yours are okay, never mind. Then you leave it one for Mitsubishi, one for Omron. So you can play both, but still can install laptop. This one already installed, right?
This one's yes.
And we already installed it. You can see the receipts on introduction.
This one, right?
Because after you install it, you get that. You can search. Go here. Go down. Look for Omron. Okay. CX1. 6 programmer. Right click here, right click says programmer. Send to desktop shortcut. Okay. Alright. So do you want to use your laptop or our laptop?
Use my laptop.
Okay, no problem. So okay.
Easier.
Easy. So usually you have a printer or no problem? Yeah. Mitsubishi is for the old model, but never mind. Just copy and edit. The new model Mitsubishi should be in another PC.
So we install a new one.
Ah, yeah. This one, USB port, right? If you remove the
Yes.
pen drive, okay. Because this one needs to be using USB. USB ports. So this laptop is good. You know, I got a lot of ports.
Yeah.
4 ports.
That's why I bring over here.
But this is the old model now. Old model laptop.
Yeah, this is the one.
Okay. Nothing is to HDMI port. HDMI port? No.
HDMI. Yeah, they have a Type-C one. Yeah, I forgot to bring the connector off. You need that one. I didn't know you need that one. So then I use this laptop.
Yes, I think you better use that laptop. But that one also got software, right?
Yes.
Okay, use that laptop. Better.
That's why I have a standby.
But not the issue because we normally during training we will use our laptop.
Reason why I need to use my laptop, I can get used to it.
Yes, that's not normal. Because my laptops I have all the software. Suddenly when you go back, suddenly you don't have one software also. What is HTML program?
So I copy out just now.
Yeah, the which files. But inside there you have the soft copy of this manual as well. This manual soft copy and the initial one.
So I copy the CF program outside.
Yes. So send to desktop.
Oh, you can see.
Yeah, you can see right desktop. The third one. Under the send to third one. Yeah. Okay.
Okay. So you know how I
So you can see from here, from there you can see this. Let me adjust a bit here. Oh, we can adjust the screen resolution.
I can enlarge a bit.
Yeah, never mind. No, for me okay. For me it's okay. If you can see that is okay. Yeah, 120. Yeah, it's fine. Okay, you open that. Open. Because sometimes some resolution only do not display. See, close. Make it bigger. Okay. Because sometimes some laptop, the newer laptops especially, the higher resolution laptop only open up only. So okay, now okay, meaning we can close this one. Close this one. Okay. Omron training. Omron numbering and addressing. Okay. Yeah. And close. Yes. So this is the one. Okay. Want to make it a slide also can. Just a few pages only. In 15 pages. You press escape.
And this one.
Yeah. Okay, right. Why is escape? No, press escape again. Why is in this format?
You want enlarge it?
No. Can you click this one? From the current slide, yeah. Okay. Start again. Sorry, today I have to talk a bit slow.
Okay, already.
Okay. Good. Okay. Now, first thing, first we learn Omron PLC lah. Okay. So this PLC is using CX programmer software.
Okay.
So this one they have a lot of models. So a lot of C series models. They call C series. So they come with the C in front. So this one is a CP1E. You see the CP1E, right? Here. CP1E. And we have some CP1L, CP1E, all these CP1L, CP1E lah, okay? And their modular type is this one, CJ. This one bigger.
Okay.
They are bigger models because it's a, you see, modular type. Okay, the one we call a compact type. So normally PLC will have two type. One is a compact, any model. They will have a compact and also they will have a modular type.
So compact is all in one here.
Yes, all in one. So here is, this is the power supply, this is the CPU, then the input card, output card, then can add on. Okay.
So people prefer this compact.
Depend on the machine. If less IO, just 20 IO, 20 input, 20 output, then I can use this.
Oh, this one 20.
Uh, Depend on small IOs, then I can use this. If more IO need to have like hundreds of IO, then I need to use it. Because this one also can add extension.
So how many models actually Omron have? Is that
Oh,
quite a lot?
a lot later we see in the software we can see how many models there. Okay, I think the one I give you is the latest one.
CP means a compact app.
No. CP is the Omron, what do you call? Their model number, and I'm not sure what they mean for CP. But the other numbers I know what they call. CP, then 1E, then you have N30, 40, right?
Yes.
For that numbers I know.
What is that?
Later. Later, one by one. So later when you do wiring, that time I will tell you what is that. So when you do project or something, you can know which model to choose. Okay. Alright. Next. Okay. So what is PLC? Okay, you know what is PLC, right? Very simple. PLC is a computer. Okay, we call it as an industrial computer, where you can program it. So you will have an input output. So if you want to control a machine or system, you can use a PLC. Very simple, very straightforward. Example like this aircon, right? Aircon also they have a PCB board inside. Means it's already programmed, right? So they will have all that button, everything. They will have this is considered their HMI. So this is considered their HMI. So this is where you set everything. Then they will have a temperature sensor as an input, and their output is the one that swing inside is rotate the compressor, everything. So that one also will have an input output. But the program they will have an IC. So they already program the IC. Okay. PLC also can control the aircon. I can take out the PCB board. I put my PLC there, all the input output okay. I connect to my PLC, I add some temperature sensors, and I can control also. So instead of using this, I can use a touchpad. Okay. So what is the advantage of using PLC? Using PLC, the advantage is okay. Currently now, the temperature sensor is only in there, right? Okay, the indoor unit. So let's say because the temperature there and the temperature here it won't be same, correct? Because there they release the cool air, right? Okay. So of course lah, my indoor unit always depend on the temperature. What is the temperature sensor? The value. Okay. Let's say I set 21, so it always depend on that. Then it will control the aircon, control the outdoor unit. If let's say I am using a PLC, I can add temperature sensors. I can add more inputs. I can add more outputs. I can add, let's say I want to have 2 outdoor units, 2 temperature sensors. I can put 1 temperature sensor here as well. So I can totally control the whole room temperature. So that is the difference between PLC and normal PCB board. So that's why in industry they use PLC. Because there's some machines I've seen before, they use PCB board. That day also I have one machine to repair, they come for repair. Because we repair PLC, HMI, PCB board and everything. Okay, we have a team for that. Okay. So it's one company. So they have a PCB board to repair. So means it's already programmed, it's a molding machine. So it's already programmed. So now the problem is they are like our laptop, they have the main IC, right, the main CPU, right. So the one is spoiled. So no choice. So they need to need to buy a new one, the new whole set.
Yes.
No, the PCB board. Yes. So now what they ask us to, because now cannot get, the machine is already old, already obsolete already. So now they ask me to convert that into a PLC. And I said no, cannot, because I have a lot of trainings now also I am handling one project for India. So that one also I haven't finished yet. Then I have continuously training. End of the year, right? Only a lot of training. Then I say no. Then I have one of my partner lah. He also doing automations. He more on projects. So I ask him to do the project. That is the difference between PLC and a normal PCB board. Have you heard about Arduino? Have you heard about Arduino? Arduino.
What is
It's same like it's not a PLC. They call it a microcontroller. Normally university students they will use that for their projects. That one is the same concept. They have an input and output, but that one is using 5 volt load.
So actually now you also can do for convert the PLC, the PCB board to the PLC.
The thing is, okay,
But PCB board got a lot of information there. But
we cannot get the information.
Yeah,
Of course, we
correct.
cannot get the information.
Correct.
The thing what we need is the input and the output. How many input they are using, how many output they are using. Is it PLC can control those input outputs? Okay, number one. Then number two, you need someone who know the machine.
Yeah.
Yes,
Yeah.
to tell you the sequence. Then only you can do that.
Meaning that you just bypass the PCB board.
Yes.
Just but some PCB board the functions still need right? Because they're quite complicated.
Yes,
You
yes,
don't know
yes.
what's actually the control.
Normally, what happens is sometimes the PCB board come with the screen itself. So everything is inbuilt.
Yeah.
So if you want to take out the PCB board from your machine and put a PLC and HMI to control your machine, can, but it's a very big job.
Yeah.
Very big job, but you cannot charge high also. That's the one problem. That's why we don't take those
Why
kind
cannot
of
charge high?
because you know why? Because if let's say they want to change the whole PCB board, let's say like you buy some second hand, can just only like less than 20,000.
Less than 20,000.
For example, it's a big screen everything. But if you want to reprogram that, and the PLC and the HMI will cost, I think only the PLC HMI will cost you around 6,000 plus. Then the programming part,
Yeah. Programming part is quite expensive because
depend on what type of programming. Just a simple programming, how is the programming
true.
Okay, good. So this is just an example. Okay, it means what I'm trying to tell is PLC, if you want to control anything, PLC can control. Even your house, your lamps, all you want to control the PLC also can. Okay, but normally we don't do that because PLC normally used for industry.
But PLC bulky, let's say you need to
Yes.
control.
Yes, but if you want to use for house, they already have a small one
So
for home automation. Okay, there's a lot of
what kind
controllers.
of brand is the small one?
You can use Raspberry Pi.
Oh yeah, Raspberry.
Then even you can use the Arduino, okay, or there's a guy was using. Normally they use Raspberry Pi.
Yeah.
Okay, can. Okay, so PLC is an industrial standard, right? Okay, that's why the Raspberry Pi all you can use for PLC. Okay, okay, next. Okay, so these are the components of PLC. Okay, so PLC will have a CPU, okay, central process, CPU lah, right? Okay, so like the PLC in front of you, the CP1E, the CP1E is combination of input, CPU and output all together. Okay, like this one, this PLC, right? The CPU is one module, the input card is one module, the output card is one. Okay, it's a modular type. Okay, then PLC very simple. You have inputs, so input digital input, so analog inputs. Then I convert this. When I program the inputs, then the PLC will control your outputs. Okay, the output is like example. You have two type of output. One is digital, one is analog. Okay. So digital means just control the lamp, motor, contactors, relays, all that. Okay. Analog means you control inverters. Okay. So this training is because you are more like basic to advanced, right? So this training, of course, we will be using the inverters. All these called digital input, analog input, digital output, analog. Okay. At the same time, you request for the communication, right?
Yes.
Communication protocol, yes.
Because now we are having a project line. We're using the robot, OTC robot, and communicate with their PLC. But the problem is in terms of communication.
What communication they are using? Modbus.
In
CCD.
Sicily,
Okay, CCD is the Mitsubishi.
Mitsubishi.
Yes.
Mitsubishi, but they're using the KN PLC.
Kian's PLC.
Ah.
Oh, okay.
So that's why now the communication, my guys do the programs up. The communication supplies, they want to put out the transfer signal. They can receive the by bit from the PLC. From the PLC, they can receive the signal. When the robot want to send the information to the PLC, they need to use a ladder that going to pass out the information.
Okay.
Surprise. Because it means that robot side had to do a lot of job.
Oh.
You see program by day, then how they put out the program to cannot be simply put. That's why they need to create another ladder diagram to send the signal back to
PLC.
Yes.
So the ladder diagram inside the PLC, right? They create.
Yeah.
Yeah, of course. They need to do some programming, of course.
You work on that before?
No, I did. I normally would work on CC link, but I work on Modbus. So I show you the Modbus. Then you can get an idea. But of course, whenever we do like these communications, additional communications, okay, like CC link or Modbus, Profibus, Profinet, device net, control net, a lot of communication.
Yeah.
You need to do additional programming. So to get the data from your any device. So that's why they will use like a term master slave. So the PLC will be master, the device will be slave. So you send signal and you want to receive the signal.
Yeah.
So you want to send signal, receive signal. It's not like straightforward. You need to do programming for that.
Yes.
So that the PLC will know what data need to send, what data need to take.
Yeah, that's why we struggle. How come they can receive but they cannot send out the information back to the PLC? That is struggle. Until you find out, okay, need to create a ladder diagram and to step up the transmit the data back.
Yes.
I said, okay, cannot using another program language send back.
Another programming language should work, but I don't know why they use ladder. I'm not sure.
Also,
But normally,
you find out.
yeah. But normally, if the PLC support a few programming language, then we can normally can use any language start to do the communication settings. Okay. Alright. Then the most important thing is the software, right? The software and the communications. Okay. Nowadays is all using Ethernet and USB, right? Those days, the last time the PLC all on they used the 9-pin, the Mitsubishi, the round pin, all that are all special cables. So you need to have all those cables to communicate. So here have different type of cables. Omron different type. Mitsubishi different type. That's why for cable only you see I have 3 buckets for cables for me. All those cables. Okay. Alright, next. Okay. Before we go into programming, we need to understand the computer numbering system. Okay. So this computer numbering actually we learned before. All these numbers, right?
Yes.
Decimal, hexadecimal, octal, right? But we did not not commonly used lah, right?
Yes.
Okay. So just refresh here. You go to next. Okay. So decimal, the normal number we use lah, decimal 0 to infinity. Okay. Then we have hexadecimal. So hexadecimal. So like decimal 0 to 9. Then hexadecimal, because they use 10 lah, base 10. 0 to 9. Then 8 to F. 16. Okay, 16. Okay. Then after this, 10 to 19, 1, 8 to 1 F. Another 16 numbers. Okay, that is hexadecimal. Okay, so mostly PLCs they use hexadecimals lah. Okay, decimal and also hexadecimal. So why? Because those days, last time they use hexadecimals for the values. Okay, because they use less digits. If let's say you have like a bigger number, let's say compared to normal decimal number, this one is using just less digits to show the numbers. So that's why they use last time computers now. Okay. Okay, next. Binary. So binary, okay. It's a 0 or 1 is a computer language, right? Okay. So of course our PLC also same thing. It's just 0 or 1. But this decimal or hexadecimal is for us to understand. Okay. For Omron, this 2 is important. Binary, of course, the PLC will of course run on binary. Okay. So 0 means 0 lah. Let's say if it is here is 15. If 15 means it's 1, 1, 1, 1. This one you can convert using your computer calculator.
Sorry, I had to write sometime. I
Can.
need to recap my memory now because long time.
No problem.
I
You can one write or one pictures also can.
had to recap my memory.
Okay. Then octal. Okay. Octal for Omron actually no need octal. Okay. Octal because they use 8 numbers means 0 to 7. That's all. So they use 8 numbers. Then 10 to 17. Another 8 numbers. Okay. So you see how all these numbers are same. In decimal 15 means in hexadecimal is F. In binary is 1, 1, 1, 1. In octal is 7. Okay. Are the same numbers. For Omron, octal no need. Okay. For Mitsubishi, yes, you need to know why. The addressing they use octal. So let us see what is addressing. Okay. Then anytime, because normally, okay, why we need to understand this? Because when we see one number, right, we need to understand what format they are using. Okay, whether it's a decimal or hexadecimal or binary or octal. Okay, then only we know okay, what value to key in, what value to see, whether I need to convert this value or not. Okay, alright.
So yeah, I forgot.
Yes.
What I call octal. 10 to 11. 11. The 17 is equivalent to 15.
Yes. So they use they don't have number 8 and number 9 inside here. So they have 7 numbers, 8, 0 to 7. That's all. There's no number 8 and number 9. Straight away jump to 10 to 17. So they're using the byte system. Okay, okay. Then later when you use them, you can understand. Okay, this is the one. Okay. So this is the example. Next. Okay, so you can use your computer calculator to convert these numbers. Okay, so So later we will be using for this Omron PLC. Okay. Next. Okay. The addressing. Okay, the memory of CP1. Okay. So CP1E have a CIO. CIO means is a channel. Okay, channel. Channels to the input area, output area. Okay. So input area is from channel 0 until 99. Output area is channel 100 until 199. What is channel actually? Okay. So here you can see the channel here. Can you see 0 CH? Okay. Then means 0 CH. So the input is 0.00, the first input. Second one is, this one is 0.01 until 0.11. After that, I continue with channel 1. Then here I can add the additional modules, extension. Okay, it's look like this one.
But you say this one is already compact, but still can be added.
Yes, like this module. Can you see the ribbon one?
Yeah.
But this one is for this Omron. This one is all Omron. For this also same, the same but as the black color lah.
So to add on additional item,
Yes, additional input of the card.
input item kind only because this one already compact.
Yeah,
So
already
this
compact.
one is
Already compared, so you can see this one is like a 40 IO.
this one 40 item.
40 IO. Can you see the 40 right? 40 IO. It means normally the input will be more than the output lah. So this one is 0 to 11 means 12 lah. 12 plus 12 is 24.
11,
0 to 11 right? From 0. 0 to 11. So 12 input here. Another 0 to 11, another 12 inputs. So 24 inputs. Then 16 outputs. Yes. 0 to 7, one channel. 0 to 7, another channel. Okay?
But you see 40.
Yeah. 24 plus 16.
Oh, 24 plus 16.
Yeah.
So means that input is actually only for 20,
24.
24.
Normally will be some PLC the input number will be slightly higher compared to the output number.
12.
Okay? Yeah?
This one is also considered as one of the
No, it's a common.
common.
Later we will learn or we do wiring.
24.
Okay? Can? The thing is, the most important thing is input is a zero channel, right? 0, 1, later on I will add means 2, 3, 4, something like that.
Sorry, I asked a stupid question.
Yes.
Sorry, for example, this one we say that I use 40, but is the 40 is actually including the input output
Yes.
all together.
Together, yes.
But input could be lesser, input could be like what you say here is 24.
Yeah.
So this one is
Output.
output
16.
16. 16. So 40, the 40 here doesn't mean
Half.
half lah.
Yeah, no.
No, right?
No.
So I have to put that aside.
Half only for Mitsubishi.
Only for Mitsubishi.
There were also some models.
Ah.
So all that we can get from the models. Then I will show you the most important thing of in PLC when it comes for hardware and also some programming. The most important, we need to know how to read their hardware manual. Okay, not our manual. This manual, our manual. The manual I show you is inside there. Okay, it will show you what is PLC, what is numbering system, all this one is there. Then later on, inside the manual I have how to create a project. Open the software, add the hardware, okay, how to download, everything you have. Okay, but some of the hardware parts, the hardware details, it's not in the manual. Okay, that one I will show from where I can get. Because for one Omron already, I think we have few manuals. One is for hardware manual, one is for user manual, one is for programming manual. Then for analog also they have another manuals. So I will show you how to get those manuals. In Google, very easy to download.
I see the Omron is more easier to get this kind of information. Mitsubishi, they
No, maybe Mitsubishi also
easy.
Yeah. Can also. But the thing is, we need to know the keyword to download. So I will show you. Okay, then. Okay. So these are the inputs channel. Okay.
CIO input channel area. Where is stated inside here?
Yeah, the channel 0.
Channel
The 0 CH. Can you see here?
channel 0.
Channel 1.
Channel
Here it shows 0 CH, right?
1. Yeah.
But yes, in the manual they just put CIO, channel IO.
Okay.
Channel input output. CIO means it's a channel input output.
So in that case, how to relate to CIO?
What's that?
How to relate the range? How can I know from the range here?
There's a 0, right?
Yeah, zero.
Okay. It means okay, what here it tells, okay, the PLC memory for CP1E, CP1L different numbers, CJ is a different numbers, but the alphabet is still the same thing. Okay. So they have a few type of alphabet. Okay, number one is the channel. Channel means the input output channels. Okay. So input area means channel 0 until channel 99. So what happened is, now inside this PLC, channel 0 and channel 1, right? Later I add on some additional modules, automatically channel 2, channel 3, channel 4, automatic. We don't need to do any settings then. Okay?
So meaning that can be up to 99.
Yes. But of course you cannot add until 99. Because this one maximum you can add is three extension only.
Oh,
Yes.
how come you can actually?
Because they already separate that. Because last time, the previous model like this white color models input is from channel 0 until 9. Output is channel 100 until output is channel 10. The previous models. Because previous models the IO is not much bigger IO. Now this one can go more IO. So that's why the output they start with 100. Okay? And the third one is serial PLC link code. Is that this means if you are using this port for IO communications. Okay, because this port normally we use for HMI. Okay, touch panels. Okay, and even the laptop want to download the program here also can use it. But at the same time, some instruments. Okay, you can use that port to communicate some instruments. In that case, I need to use these channels. But of course, these channels they already give you the information. Channel 0 is there, channel 1 is there, right? And channel 100 and 101 is the output. Okay. But for this information, you need to depend on the manual. In the manual only they will tell you, okay, you are using this instrument, using this port to communicate, and this is the data.
So this is another device, PLC link.
Any instruments.
Any instrument.
Yes. Any instrument that can give you data using serial. Serial means that communications. Yes. Okay. So you need to use this kind of data. Okay. Then auxiliary area. Okay. Auxiliary area means like system data. Okay, the system data, the system value means here you can get the status of the PLCs, whether it's an error, the battery is low data, okay, and what else? Communication data, all that data. Later in the software I can show you which data. Okay. So whatever data of the PLC, they call normally a common term is the like system data. Okay, you get from the auxiliary area. Okay, then this one all for programming. So if you're using timer, it's a T. If you want to use counter, it's a C. Okay, then if you want to use data register means value. So in the HMI you can see the time what is the motor speed, what is the temperature value, everything will be under data registers. Okay. Then we have a holding area and book area. All this for our program. Okay, because normally our program, okay, we know the input is channel 0, right? Input is channel 0, right?
Yeah.
Example, okay. So let's say we connect one input then. So you need to program at 0.00. Okay. Then what is the output? 100. So 100.00. This is very simple. But sometimes our program won't be simple like this. Right? Because I on, then I need to run a timer. After the timer, on, off, right? So for that for that programming, we use all these functions. Using timer T, using counter C. If you want to use values T. If you want to do this one, these two for programming, like we call like an internal relay.
Okay.
Okay, you know PLC is developed from relay system, right? Because before PLC, what they use? They use relay to control your machines. You have a push button, then you have a relay, you have a latch relay, holding relay, right?
Yes.
Then you have a timer. So all those they replace using the PLC. So now no need relay, now no need the timer, now no need the counter.
Yeah.
Everything is inside the PLC already. So, but if you want to do programming, sometimes when I press start, okay, timer need to start first. Then after 5 seconds, then only the motor need to on, for example. So you need to do some programming delays, everything, and for that you will be using the holding area, work area.
Oh, sorry, again. For A, usually what kind of this called?
Okay, A is the system data.
The system data.
Yes, it means let's say the system got error because of the battery problem. Okay, so what happened? The PLC will store the battery error information in one auxiliary area. Okay, one of the auxiliary, because of 700 plus, right? So one of the area, the PLC will store the data. Let's say battery error. So later, if you want to use, okay, for example, I forget really what number. So let's say 531.0, for example. Let's say this is the battery fault address. I can use this. Then I can create alarm. In the HMI, I want to show something. So for that, we use this. So later we see what are the data we can take from it.
The data register?
Data register is for value.
Value.
Yes. If you want to store values, it's data register. If you want to store just on off, okay, you can use the work area.
What area for?
If you want to store on off, yes, work area or holding. Normally work area lah, holding area no. Okay.
Holding area is for?
Holding area for programming. If you want to, okay, when I press that, I want to latch. I want to hold first. Later on, when we go into more deeper, then you can understand it.
Okay.
Okay. So just I want to show you. Okay, these are the memories the PLC have. Okay. Okay. Go to next.
So every time the system the system itself, the data is also come from the head.
Yeah.
From the head. It's not defined by us, right? This one defined.
The information of your PLC is from the APS.
Information. So we just set that one as A.
Yeah.
From the machine.
Yes.
Okay.
Okay. Okay. Now, so one channel. Okay, you see, one channel they have 16 data. Okay. They call 16 bits. So under one channel is 0.00 until 0.15. Okay. But this model you see until 0.11 only, right?
Correct.
For input.
Yeah.
Okay. Because DCP1E only use 12 data only. Okay, 12 bits they call bits lah. Okay. But normally in one channel they have 16 bits. Okay. Same for output also. Okay, go to next. Okay, you see. Omron CP series is this one, the compact model. Okay. Then Omron CJ series is the modular. Okay. For CP series, like this PLC, right? You see, okay, one channel they use 0.0 until 0.11. Only 12 inputs they use. Okay. So what happened from the 0.12 until 0.15? It's not in use. Okay, it's not in use. Same for the output. Output only use 8, means 100.0 until 100.7. So 100.8 until 15 is not in use. But modular type is different. Okay, modular type because each module is a 16 I/O or 8 I/O. It means some module is a 16 input, some module 16 output, or some module is just 8 input. Okay. In that case, like this CP, right? Channel 0 means is an input. Channel 1 means is an input. Means channel until 99 means is an input. Channel 100 above is the output. Right? That is for the modular type. Okay? For the compact type. For modular type is based on the slot. Okay? Based on the slot you have. Let's say the first slot is an input. It means the input address will be channel 0. The second slot, let's say you add an output. So the output address will be channel 1. So you cannot apply this format here. Okay? This channel depend on what are the modules you have.
Okay. So that's the difference of CP and CJ.
CJ, yes.
So
The compact and the modular.
So modular one, like for example, channel 1 can be an input, channel 2, channel 0 can be an input,
Yes.
channel 2, channel 1 not necessarily can be an
Input, yes.
can be out,
Can be output.
can be output.
Yes.
That's a difference.
Yes, because so this one is based on the slots.
Yeah, based on the slot.
Yes. So normally that slot 0, 1, 2 input. So it means that channel 0, channel 1, channel 2 is the input.
But what you mentioned about compact PLC, they also can have a slot, right?
Yes, can have a slot,
Yeah.
but it's already fixed the numbers.
Yeah.
Okay? Okay. Can I erase here? I will show you here.
Okay.
Okay, good. Okay, so for you see, for CP, okay, CP because they have CP 1, E, L, CP1H. CP1H. Yeah. They have this type of models lah. Okay. But now we are using CP1E lah. So later we will be using CP1L because that one is for Ethernet port. Okay. For For CJ, of course lah, CJ1 or CJ2. And CP also same. CP also CP1 or 2. Okay. Now you see this CPU. Let's say one PLC. Okay. So they already have PLC now. Already use channel. So this is the input. This is output. So let's say they already use channel 0 and 1. Output also channel 0 and 1 based on the number of IO lah. How big is this one? Okay. I think the biggest one is the 60 IO. Okay. Yeah, this one. This one is 60 IO. This big one.
60 IO.
So I think we will have 3 channels.
This one.
That's the cover. Okay. See from 0 to 11, okay, one channel. 0 to 11, one channel. 0 to 11, one channel. So channel 0, channel 1, channel 2. Output also 100, 101, 102. So if I add here, it become 0, 1, 2, 3, 4, 5. Okay. So let's say I add a module. Let's say it's the input module. So automatically become channel 2. Okay. Let's say I add the output module, automatically become channel 2. Because it's based, the previous one is 1.
Okay.
Let's say I add here is the input output module. It's a combination lah. So automatically become 3.
So the channel is really important.
Yeah, of course. Because then only we know
which PLC
which input to program.
Okay. Let's see.
So this one we call addressing.
Okay.
Addressing. For CJ series, the first one will be the power supply. The second one is the CPU. They call CPU. Okay. Then let's say I had a DI pipe. Okay, so channel 0. Input. DI is the input, correct? Okay. Then let's say I had another DI. Channel 0. Let's say I had a DO. Sorry.
Channel 1.
Channel 1. Then another DO. Channel 3. Let's say they add another DI. Channel 4. So the addressing use the channel to do the addressing format.
Understood.
Okay, good. Okay. Next. So you see, I use a lot of whiteboard to explain. That is my way lah. Okay, because this slide after a few slides, this one finished already. So later on when we do programming, everything, I do my whiteboard won't be empty. Okay, so anything want to take note or take picture, okay, before erase just be the way lah. Okay. So this is about your hardware there. Okay, I don't think so. It's the same thing in my mind. So inside here we put a battery. They also got battery. But careful the one because you know when you touch here, because it's too easy. Okay, battery I think here.
Battery is for what purpose?
Okay, to keep the value.
Okay.
Okay, so some PLC different purpose of using battery, some PLC different. Like Omron battery is to keep the values. It means, okay, just now we see data register, right? So to keep the data register values, because okay, let's say you do program for motor, okay, then you keep some value. That means what is the minimum set point value, what is the maximum set point value, everything. Now if you off the PLC and on, what happens? So all the value will lost. Okay, so if you keep battery, so the battery can keep these values. Some PLC, the battery is to keep your program. If the battery is spoiled, power off and on, program will lost. Some PLC, like LG, Bradley, all that. Like Mitsubishi, Omron, some PLC is to not protect your program. Is the value, to keep the values. If no, the value will come all the
As long as you turn off the machines, you will shut down.
it will still keep the value.
Yes.
When you open back, the value will be there.
But if the battery die already, gone.
All the value becomes zero. The program will be there, the logic will be there, but all the value becomes zero.
I don't know how people about changing of the battery.
Omron and Mitsubishi not that.
So far, I
So
know
far,
I
because
found
normally battery can last for 5 years if you're using. If you're not using, 2 years plus. Some PLC not like that. Some PLC the battery is very important.
but the data is not so quite, because when you turn on the machine, you run back and you store back again the data by itself, right? So it's not so critical. Right?
Some data we manually sometimes we key in the HMI. Sometimes right, some data, not all the data, of course. Let's say I'm using hundreds of data register. Of course, not all the data register I need to key. Some data register, right? Minimum value, maximum value, okay, all that. Okay. So what happens when I power off and on, the battery gone, all the value becomes zero. So I need to refer to the manual again to key in the HMI. Some set points, all that. Okay.
I see.
So later on when we do programming, we know lah. Okay.
No battery also can.
That is
But it depends on how critical it is.
Yes, depend on how important the data register, for what you're using. Okay.
Same like our robot as well.
Oh, they have battery.
Battery memory.
Oh, okay.
Are you familiar with the robot?
No, not much.
Robot arm.
Yeah, I know, but not familiar with their programming. But I know they're using what the G code, right?
They also have a G code. I'm not sure what kind of G code. It's robot language.
Yeah.
So they do have a robot as well. Like they do have battery also. Same like what you mentioned here. You keep the data and let's say your battery out you lost the memory.
Because that's the thing. Because we don't get a lot of requests on this type of training, PLC and robotic. If I get a lot of trainings, then I can buy one robot arm, connect with the PLC. Because it's very rare. People request for this type of training.
For
Robotic.
For cobot and industrial robot is a bit slightly different. Industrial robot quite sensitive, but the cobot one is quite because it's light industry.
For use the line.
For in terms of safety wise, can be more not so not harsh.
Yeah. Because I know last time there's one participant from Sabah. He used KUKA.
Yeah, Buka industrial.
KUKA robotic arm. He said the small one will be this big. They very cheap only. I think less than 5,000 only.
Buka industrial so small.
Small one. KUKA is like
Usually
yellow color, right? No.
Yeah, orange.
Orange, yeah, yellowish orange, right? Yeah. But you see, but the small one only. That's because that one they use for their training and everything. But that don't need to keep. That one they use for training and everything. He said that one they have some new features. That is, you like free run, then you can set the value.
That one is not. That one is a cobot.
That one is a cobot.
The one he mentioned is a cobot. It's not industrial robot. Cobot. The industrial robot you won't let you free.
Yeah.
Cobot is like swung on the head.
Yeah, but it's not Kuka brand, they don't have that.
I not heard that Kuka have those kind of small. They usually industrial.
I know they just have the big robots, right? Okay. So then the in the input side you have a channel 0, channel 1, right? Okay. Then the power supply. So like this one is a 230 power supply, 230 volt. 230 AC lah, AC power supply. You power up the module lah. Okay. Some module is a DC 24 power supply. Okay. Then here is the expansion slot. Okay. Then here is the output. Then we have a RS232 communication port and USB port for programming. This one is for programming and also communication. Means like the HMI and all that. Then variable resistor. Okay, I think this PLC don't have variable resistor. This one the older models variable resistor. Variable resistor is like a built-in analog input. Okay. Then you have an option box. I think that model don't have an option box. Okay, don't have. Okay, like this option box. I think the picture is this PLC.
For what?
Okay, you want to additional. Okay, like this. You see, this PLC CP1L come with a Ethernet port.
Okay.
Okay, so they don't have RS232.
RS233. No.
So if you want to communicate using RS232, okay, just buy one RS232, connect here. This PLC don't have analog inputs. If you want analog inputs, just buy one, can connect here or can add at the side as well analog inputs. But just need like this one is a 2 input 2 output.
They call options box.
Option box. Yes.
Okay. Oh, interesting.
Yes. Some model have, some model don't have.
Get the picture.
Yes.
Interesting.
Yes, of course.
Now I discover better.
That's the advantage of people coming training here. Because sometimes some company, because if more than 5 packs, we go to that company to training lah. But if I go there, I only can bring that. I cannot bring others. If they come there, they can see our other hardware.
So that's why last time when they do the what the heck is that so heavy? What the heck? I can't understand that one. What the heck? When they do the assembly.
Yes. Okay, good. Then this is one example of the programming lah. Programming example. Okay, next.
That one is a Q, right? Or output.
Which one? Q.
It's a Q.
Q.
What is Q?
Okay. What happened in the that's the one confusing thing. No Q here. No Q here. Okay. So what happened? When it's the input, when it's the input channel, it become I. When it's the output channel, it become automatically Q. You don't need to key in. You just key in 0.0 only. It automatically I. But later when inside the program, I show you.
Oh, is that?
To let you know, okay, very simple. Okay. Like this, right? So channel 0, correct?
Yeah, correct.
Channel 0 means until what? Go to next. Go to next. Okay, go back. Okay, here. Like this PLC channel 0 until 11.
Yeah.
Okay. So when you key channel 0.0, okay, automatically I in front.
Oh.
Okay?
300.
Automatically Q. Okay. When you key in 0.12, it's not there, right?
Yeah, it's
Not there, right? So it's just show like this only. It won't show I. Means physically it's not there.
Yeah.
So what happened? It become a internal memory automatically. Search for the output. If it is 100.00, it shows Q, right?
Yeah.
If let's say I add another output, then it's a 100.09. So it won't show the Q.
Okay.
Because what is physically is not there. Because physically I am until 0.7 only. Not here, not here, here.
Okay.
These two.
Okay.
Because I'm physically until 1 level.
Okay.
Okay. But in this PLC, then okay, like this, right? In this PLC for the CJ series, okay. If I key in 3.0, okay, 3.00. Okay, 3.00 is what? Output. Automatically Q. Okay. Let's say another output. Another output is what? 2. Okay. So let's say I put Q, sorry, 2.15.
2.15 memory.
No, still a Q because can go up to 15 or 15, right? So let's say I put 5.1. So it become a memory because slot 5 is not there. So that is to show which one is the physical input.
But in terms of memory, what is the range?
Memory range.
Because not integrated, then it become a memory.
Yeah.
Then how later how we
Use
find it, we call it.
Later when we do programming. But the thing here, there's a trick here. Now you see, channel 0, channel 1, channel 0, channel 1 is there. So it can indicate you whether it's a physical input or just a memory. But channel 2 and 3 is not in your hardware. So when you key in like 2.0, right? Okay? Sorry, this one is 100, right? Correct?
Yes, correct, 100.
102, 103. So if you put 2.0, it won't show you the I. Even though 2 is the physical input, because it won't show you the I.
Why?
Why? Okay, good question. Why? Because when I do programming for CP1E or all these models, so I only in the initial stage, okay, I will choose what is the model, whether it's a 30 IO, 20 IO, 40 IO, or 60 IO. So from there, if the software will know how many channel input, how many channel output. Okay. Then later on, when I add this in the programming, in the configuration, I don't need to do anything. Okay. So for the programming, he won't know the 2 is physical input or not. As a programmer, we need to know. But whereas this one, because when I want to do program for this, there is another set page for configuration. There we need to tell, okay, the first slot is this, second slot is this. So for this, it will show all the Q and I according to your slots. But here is not. Okay? Okay? So later in the programming I can show you.
Is that because if let's say you key in 2.0, it's supposed to 2.0?
No.
Something like that, Sure.
You know why? Because when you choose the PLC, okay, you tell 40 IO, means the software will know channel 0, channel 1 is the input, channel 100, channel 101 is the output. That's all. Later on when you add, right, the software won't know whether you add or not. So that's why the software cannot tell you channel 2 is the input. Okay, but whereas this one, you need to tell the software that slot 1 is this, slot 2 is this, slot 3 is this. So when you do programming, it will follow your configurations.
So should I tell the software that this tool is
No need, you cannot tell the software. So when you do programmer need to know. So this one, okay, slot 2. That's why they put automatic.
but it will
Of course.
still be input, right?
Yes, of course, still be an input. But only thing is it won't show the I.
What's the difference with CP2?
It's a new model.
It's a new model.
Yes.
So what is it?
CP2 is a come with the, okay, it's very simple.
L and H. L is the one that
L is normally come with L.
open ocean slot.
No, E also can.
E also can.
This one is a CP1E. Also can. Okay, some model cannot lah, some model can. Later I will tell you which model can, which model cannot. Okay. Then CP1L, you go back to the memory area. Okay. This memory area, where is it? Starting from the timer.
Memory starting from
The timer.
timer.
Starting from the timer until the work area. Work area, I think same. Starting timer, counter, data register. More in the CP1L. Okay. And CP1L, some will come with the built-in Ethernet. CP1E don't have. Okay. Then the CP1H also same thing. They have more number of memories. So means the memory is big. Okay, that is number one. CP2E, now they only release CP2E only. They don't have 2L, 2H, 2E, just CP2E. CP2E come with Ethernet also. Because earlier 1E don't have Ethernet. Now 2E got Ethernet.
So the E1 is considered as a basic one.
The basic one, yes.
Basic, then the more medium one, then more
advanced on the compact version.
compact version.
The small, the medium, the big one in the compact version.
Why they choose EL version?
That one I don't
EF.
That one I'm not sure. Why is it E, L, H?
Understood now.
Okay, good. Okay. Any question until here?
So far all good because I asked one question.
Yeah, sure, no problem. That's the advantage.
Everything I not clear, I ask them.
No problem. That's the advantage of one PAX. So you can ask whatever you don't understand, you can ask because then only I know whether I can go to the next topic or not. If this one is not clear, when I go to next topic, so when I touch here again, then you will confuse. What is this? Why is this? So anything not clear, just can ask me. Even sometimes I have like maximum I will take 10 packs lah. But 10 packs is mostly same company.
Yeah.
If one packs, I maximum take only four different students lah, from different companies. I don't go more than 4. If same company, 10 days. Okay. So, but if you ask me, the best one is two packs. 2 or 3 packs are the best one. You know why? Because they have different questions. You have different questions. So when you ask, he can learn. When he asks, you can learn also. But this training I cannot take because it's you combine 2 right? So I cannot take this. Okay, never mind. Okay, so what's 10:50. Okay, never mind. We take a break. Okay, want a coffee or tea? You can make a coffee or tea. Then after the break, we continue. Okay?
5 minutes, right?
It's depend on 5
No, I hear about it anyway.
Yeah. OT?
Alternate.
Okay. Okay, this one later we see. Next, this one later we see. Okay, can escape. Okay, can minimize this. Okay, now you create a folder in the desktop. Whatever program you do, you just can save it here. So you can put your name like Omron something. Purchase program. First thing what we want to do is we want to do a backup. Okay, backup means from the PLC to your laptop. Okay, go to PLC, auto online. Okay, now can you see got 3 types? Okay. If you are using CP1 or CP2 Ethernet, okay, means a CP2E or CP1L, then I have to use this. Okay. If you are using Ethernet IP, means in the CJ series, if you are using the Ethernet module, like this, like one communication module, then it's this one. Okay. If you are using the USB or the serial port, it's the direct online. Okay, connect the USB. Okay, direct online.
I also can do this one, right? This one,
Cannot.
this one with
Ethernet.
Okay, okay. And then online is this one, USB. This one is the slot.
Okay. So USB or serial lah. So of course serial you cannot choose because the laptop haven't detect the serial. If the laptop detect the serial, then only it will show you. Okay, USB, okay, connect. Okay, you see do you wish to transfer program from the PLC after online automatic? Okay, so I want to transfer lah, right? Transfer IO table and special release data. Okay, this one only available for this unit. CJ series, because the CJ series only we do the IO table. But this one don't have the IO table. But normally what I tell my participants, for both also you just select. Okay, click yes.
Because this one haven't turned on. You need to turn on?
Yes. Why not? Okay. That one no problem. Okay, do again.
Okay. Okay, searching.
Okay, upload successful. You okay? we already successfully back up. Okay? Can? Save.
Save to the desktop system.
Yeah, the folder. Okay, we just name it as a upload day 1.
Upload day 1.
Yes. Okay, see. Okay. So this is the backup. I'll go to file. So we create a new project. Okay, new. Okay, the device name you can put any name.
Okay, let's double check the device here. Just sign it over here. Sign it over here.
Device name.
Same push. PLC 1.
Input PLC 1.
Okay. Okay. And the type.
Okay.
The type here, you click. So this Omron sales programmer can support all these types. Okay. The C, you go up. For so many models, go up.
CP1E.
Go up, go up. Okay. This C100s and C200 is the older model. Is the big one. This big.
Just not that one.
Which one?
Yeah.
Similar to this, but this one is a Siemens.
Oh.
It's a Siemens, but similar to that side. Okay. Go down. Then the CJ lah, right?
Yeah.
CJ1M, CJ1H, CJ2M, CJ2H, or that.
They also got just now you mentioned asasmy M, but they also got
F, G, and H also. Okay.
The fundamental one will be G. Yeah.
You mean the
The
high,
basic one.
high spec.
Low spec.
Low spec. Okay, you click that. You click the. I also don't know, but I never explored it. Okay. Just click. Go to setting. So it's a 10K step. Okay.
Close.
Close. Click here now. Click here. You go to the CJ1M. Go to setting. 5K step. Okay. You click here. 23. 20K step. Yeah, almost same lah. Because 20K is the number of the size lah, the program size. The program area size. 20K
No,
step.
no,
No, not IO. Steps means this one right is considered one step. 1, 2, 3, 4. So means maximum can go up to 20K. Yeah. Okay, then the CP series lah. The CPM also got. CQ, this one not old model.
no more.
Yes, CS, all that is old model. Now it's already obsolete. Now they have the CP2E, CP1, CP1M also don't have. Now CPM also don't have. They have CP2E, CP1, all this model lah, all this model and this models, CJ series. Now they go to C-spec already.
So the newer version is what model?
NX.
NX. So not here, right?
Not here. It's a C-spec Studio software. It's another software. Totally different. Okay?
Do you have the software also?
Yeah, I have software.
Yeah.
It's a second software. Okay, so you choose CP1E. Go up.
Okay.
Yes. Then go to setting. Okay. Ours is what?
40.
N40.
N40 SDR.
Yes. So look for N40.
Okay. 8K step.
Yeah.
Okay.
Okay, clearly.
Okay.
Okay, so the network type I'm using USB. Clear. Not legal name. Okay, clear. Cannot have
Space.
yes. Okay. So this is the software. Okay. So all the instructions. This one called instructions. All the functions like case here, normally open, normally close, output. Okay, the ladder one. Okay. And the rest is the shortcut. Shortcut of all these functions. Okay. And we see one by one. So what we do? So here, go to symbols. Double click. The symbols have already a few symbols based on the PLC. There are some symbols, some PLC got more, some PLC got less symbols. Okay, it's already built in. Means okay, if you want to use like a 1 second pulse, you can use this address CF10. It's a special one. Okay, like I said, you see, low battery is under A402.
The
Auxiliary. Yes.
auxiliary.
Cycle time error, first cycle flag, first task execution, all these are
This one is inside this.
PLC. Yes, this model
This
CP1E and 40.
But you say from the system.
Yeah,
From the
from the
system.
PLC lah.
Okay.
From the PLC. Okay. Then there's others also. The others must get from the menu. From the menu only we get. Okay. So later on we see lah. Of course we cannot see all the auxiliary. So some we will later use. Okay. Okay. Go to setting. The setting here later we do. Later. This one is the PLC settings lah. Okay. Okay. Go to memory. Yes, all these memory areas. You double click. So here you go to A auxiliary. So here we can see all the values if we online lah. Currently we are offline lah.
Okay.
Okay, currently we are offline. So if you are online, you can see some values here. Okay. Right, that is under memory. Okay, close. Then okay, under the program, okay, new program, section 1. Okay, open. So this section 1, you can rename the section name. Okay, and you can add multiple sections and multiple program like this. So means you can arrange. It means that it's not like this program run means the other program not run. Not like that. The PLC always scan all the program at the same time. So you can have like a conflict, programming conflict, make logic conflicts. Okay. So later we see that what is that conflict. Okay. Now we do a simple program. Just stop. Okay. Go to section 1. Okay. So how to do it? Very simple. You click here, then come and click here. Okay. So it asks you to put new contact. Okay. So the new contact. Okay. Key here 0.00. Okay. So it asks you to put comment. So each one will give a comment. So let's say start. Okay. Yes. Okay. Then the output. This is the coil. Yeah. Then you click here. Okay. 100.00. Motor. So when I press this, the motor on. When I release, the motor off. So this is the push button lah. So I want to keep on the motor. So if I want to keep on the motor, I use a latch here. It's a or function. Yes. Same 100.00. Okay. Then if I want to off the motor, I put here normally close. So you add a normally close. 0.01. The next input.
0.01.
Yes. Okay. Escape.
No, make comment.
Need to make. I think you double tap enter. Enter. Okay, put a comment. Stop. Yeah. So if you forget to put the comment, okay. So you press escape. Escape.
Escape.
So this is the one. Okay. Now you just take any normally open or normally close. Just put it here. You key in 0.12. Okay. No need to put name for it. Okay. Can you see for 0.12? No I address. Okay. So just you put beside here. 3.0. Clearly? Can you see? No I. Because, you know why? Because only the channel 0 and channel 1 will have the I. 1.01, yes. Until 1.11 also you can. Okay? You know because why? Because why? How the PLC software know? Because just now we choose 40I. So the 40I means you know, okay, this is the input and channel output channel. So later on when you add, is there any place to tell any place to add that I adding here? No. Because there's no IO table. When you choose this PLC, then only you get the IO table. Okay? Just delete this one. Delete it. Yes. You can use the delete button also. Okay, wait. No, wait. Cancel. Okay, wait. So, when you this one, right, once you finish writing, right, click yes. Then you press escape. Then only it become a normal cursor. Or you can click here. If no, because if you choose this one, it's always that symbol only. Okay, good. Okay. Once finish, done. Okay, you save first.
Save under
Your folder.
input PLC 1.
Yes. Only input PLC 1. Day 1, lesson 1. That input the PLC 1 name no problem. Day 1, lesson 1. Okay. So once done, what we need to do? So now we need to download, transfer to the PLC. Just now we use we upload, right? Means from the PLC to your laptop. Okay, now we are download, transfer to PLC. So first thing is go to PLC, work online. Yes, about to connect. Yes. I need to work online first. Okay. Okay, when you see green color like this, it means it's online. can hear also you can see. It's run mode or monitor mode. Offline means it will show offline. Okay. Then you go to PLC again. Got two steps. Transfer to PLC. Yes.
Just now it's outlet, right?
Just now is from the PLC, right?
Yeah.
But we didn't click here, right?
Yes.
Correct, because we use the auto online.
Okay.
What we did is we make it auto online. When you do auto online, it asks you to upload. So we upload.
Mm. So transfer to PLC.
Yes.
Okay. Transfer on.
Yeah.
Mission continuous. Mission that performs
Okay, so you see, I make sure there's no problem. Okay, close. Close now. No. Now one more. Okay, now we don't have a buttons, right? So still we can test it out. Okay, what you do, you right click, set on. Okay, ask you to change to monitor mode because now it's a run mode. Okay, yes. Yes. Okay, so you see, it's a on off like a push button.
is a power.
It's a pulse. Okay, so that is the reason I do the latching here, because I start motor on, then it can latch until I press stop. Okay, right click the PLC, stop, on. Means I push it and press the button. Okay, on. Very simple. That's all. Download, monitor. The difficult part is the programming.
Okay.
Upload and download is very straightforward. Okay,
So it's a transfer.
transfer to PLC.
But between just now you transfer the data from the PLC to PC. Inside here still have the data.
The whole program.
Still have.
Yeah, the whole program.
It's just only transfer.
Yes, just you are just copy the file only. But when you do this one, when you transfer to PLC, your program to the PLC, it means it will override.
Oh, means that the previous data no more already.
No more already.
Okay. That's one.
So once you download, once you transfer from your laptop to the PLC, the previous data will be erased, replaced with the new data. Okay, good. Okay. Now, so when you online, you can see the error, everything. Okay, later we have an error, we can see what is the error. Because now this one we don't have any module to create error.
I want to see what is the program file name.
It's a CX.
Dot OTP.
No.
OPT.
No, this one. This one, CXP. You make it bigger. No, you go to view, file name extension. Yes, CXP, CX programmer.
The OPT is
OPT is nothing. You can delete. OPT is like a backup file.
so no use.
Not use. If you want to, if let's say like you want to share this file to someone, right? This the CXP, OPT, OPT, right?
CSP. Okay.
Okay. now we want to add a timer lah. Okay. So want to do some modification. Go to PLC. Go on. Means just now when I click means online lah, right? Again I click means like I'm off. Now I can add any additional programming. Okay. So now I want to add a timer. Okay. So this is considered. Can you see zero, right?
Yeah.
This zero,
Yeah.
Okay. This is considered the rung. This one we call as a rung.
Run. R-A-N.
R-U-N-G. Rung.
R-U-N-G. Okay.
One rung. So one rung, only one line. Means can have multiple branches, no problem. But this is considered one line, correct? This is considered one. Okay, so if already finished, then I go to next one. Okay, click here. Okay, I normally open. Put it here. The add a motor 100.00. Okay. Okay, motor. Yes, automatic. Okay. Then I want to add a timer. Okay, for timer, must use this instruction. Yes, you can put it here automatically. It go to end. Okay. So the timer is TIM space. Okay. Timer also have address number, right? T0 until T255. Okay. So you can put timer TIM space capital. I think automatic capital. Automatic capital. Space 0. Timer 0 lah. Space. Okay. So this one is a 100 millisecond timer. Okay. You put hashtag yeah, 100. Yes, means 10 seconds. Okay, 100 means 10 seconds. Okay. Timer 1.
Usually prefer capital or capital. Your practice
Capital are the first one.
all capital.
Not all capital, all capital are the first letter capital. It's like normal lah. Like if you, it's a standard practice lah, right? But that one not the issue.
No issue.
Normally, because if you see, sometimes when the company programs, normally we don't use like this. Timer 1, start, stop. Sometimes it's just a short form, TMR 1, all short form. Because sometimes we want to put something, we make it like a big, like a word. Okay, timer, 10-second timer, or motor off timer, sometimes right, or motor delay timer. So we cannot put motor delay timer. So we put MTR, DLY, TMR. So make sure you can, when you see it, you can read, you can understand also.
Yeah, I'll make sure you understand the programmer can understand about other people maybe not.
Can, but that's why we don't put too short. TMR still can understand, right? Moto MTR still can understand. That's a short form. And sometimes they don't even put moto. Sometimes they put according to your wiring diagram. Sometimes the wiring diagram they don't put moto. Right? Some tag number, right? They use that here. Sometimes they don't use start stop. They use PB. According to your wiring diagram. Let's say in the wiring diagram, the first push button is a PB01. Second push button is a PB02. So they use the same number.
Better to have.
Better to use that way.
Better way.
That way because easy to troubleshoot.
But if you put the name, then
Start, stop.
timer, then the number reference ball also can, right?
Yeah, can.
Because otherwise it will be sometimes confusing what the number will be.
Yeah, because if you see, I try to see the company projects that I have. I can show you company programs. Funny names. So when you see the name, you cannot understand. Like this, you see motor or you put MTR. When you see that address, you know already, okay, this address, this output is linked to a motor. But if you see company program, sure you will run. The only thing you get the data is okay, 100.00, right? You open your wiring diagram and see 100.00 is connected to what. Then only you know, oh, okay, it's a pump, it's a motor. So the two things is very important, troubleshooting the wiring diagram. Okay, so I start motor on. When the motor is energized, I use a timer. This timer is you see 100 millisecond timer. Okay, means 1 equal to 100 milliseconds. So if you put 100, it means 100 multiply 100. So you will get 10,000 milliseconds. So that's why we put 100 here.
100 is
One is 100 milliseconds.
Why is actually 100?
So if you put 100 means it's a 10,000 milliseconds. So this is considered 10 seconds. And it's a BCD time. That's why we put a hashtag. Okay. What is the BCD? Later we see. Okay. Then after the timer I want to off this motor. Okay, you put normally open. Put it here. Yes, sorry, normally close. And here the T0. T0. Yeah. Okay.
How can you recognize T0?
Because T0 is the timer 0. Escape. T0 is the, because timer number was 0. So you put T0 is a timer 1. So it means this timer, this is the input of the timer. Okay? Then this timer, the output is the T0. So how this timer works is TMO. Yeah. What do you do? What do you want to do?
I want to see the timer.
TIM.
Yeah.
Space.
Need to say space.
Space 1. Space. Value. Hashtag. Any number lah. 100 or 150. 1 also can, no problem. Okay.
This one is
Name no need. Okay.
this one.
Okay. But okay, this one is red color means it's a wrong because there's no such thing TM0. That's why it's red color. Okay. Then why this one is red color? Because in the same line. Cannot have two times. Delete. So how to draw this line? You click here, very easy. You can use this or you use control and use the arrow. Yeah. Okay. Save. Okay, now transfer to PLC. So first online, go to PLC, go to online first. Yes. Then into transfer. Go to PLC.
Online first and transfer.
Yes. Okay, to PLC, yes. Now no need to transfer all because the setting all transfer already, right? Just the program setting only, the others okay. Yeah.
all is also okay.
Can also, but why I don't prefer transfer all? Because transfer all is including the settings. First time you download the settings, okay. Because second time, third time you download, no problem, not an issue. Okay. Why I don't advise? Because you see, when you do something right, when you repeatedly do something, you used to it already. Correct or not? Okay. When you repeatedly download all, what happened? You even do a small change also, you will download all. Correct. Well, let's say there's an original program running. You open, you see, then you see, okay, this one normally open only. I want to close, no, put normally close, right? You change to normally close, then you download all. No issue, no problem. Why I don't prefer that? Because sometimes, let's say this is your company project, company machinery program. You go to your settings. Example, you go to setting, you just want to check only. Click yes. Okay. Go to settings. Then you just go and check only. Okay. By mistake, you change some things. You didn't realize you changed it. Okay. So when you download, this setting also will be downloaded to PLC. And it's suddenly the PLC behave differently, right? You cannot find what is the problem. Because what you will think is, I just change only normally open to normally close only one. But why suddenly behaving like this? So we don't know. So that is the reason normally what I do. I only download what I change. So let's say I change only in the program. I just download program. Or if I do something in the settings only, I don't want to catch up the program, then I just download the settings only. Because the settings are so many, right? So let's say I do something, because it's already as a program. I go to do settings, so I just transfer the setting. I don't transfer the program. The same thing. Without our knowledge, we just go and change some program. By mistake you delete, by mistake you add. You didn't realize. When you download, you will download. So you cannot identify what's the problem. So to avoid all these problems, so always make sure, if you want to download, you make sure, okay, where I do changes, program, just download. When new project, then download.
But sometimes you don't know where you change, you forgot. Then
So the best way is always have one backup. That's what normally I do. Normally when I do troubleshoot, normally what I do, I will create one folder for, let's say I'm going to company A. So I like my laptop, okay, I put company A one folder. Inside that folder, I will create another folder backup. So I backup, I just put inside that folder. I don't touch the part. Sometimes what happens, I do another backup, or I just save as the original backup. That backup I just open, see, monitor. Because when you know about PLC, sometimes you just play, change. Okay. Of course, when you're new to PLC, of course you don't touch. But when you're used to it, right? So sometimes what I do normally, I will just go and change and see whether the output is working or not, to make sure that is the problem. Because sometimes they say this output not working, but not actually that is not the problem, maybe other problems. So to make sure the output working, sometimes I just create some bypass program and check. So sometimes when I create something, then you create here, add here, and sometimes you forget what you do. So I always, if I messed up the program, I always go back to the program. So that's the best one.
I just worry sometimes, let's say for example, I thought maybe some setting you forgot, you change already, but you just download the program only. But if the program might be not work according what you suppose, because you did some setting, you just download the program. Then will be issue later on, right? When you transfer this to your PLC.
To your PLC or to your backup?
To PLC. Because like for example, you make the
Okay. So we have a program and the settings. So we do some settings as well. We do some program as well. But you will only download the program.
I just download the program from to here.
Yes.
Then it might not work according because your one
The setting is different. Yes. It won't work.
it won't work, right? So she's supposed to be transfer everything to be good.
Yeah, in that case, yes. I download both. If I didn't do any settings, I just do the programming part. Yes, I download the program. Any PLC also say. This will always have two data. You are downloading any PLC. One is the
Maybe you share me what is the reason just only let's say like for example setting you not change but you just copy the data. I thought everything copy.
Okay, good.
Is that because of memory issue or because
no,
of
not
time?
memory issue. Very
Then-
simple.
Then just direct copy everything.
Okay, I will tell you very simple. Okay, go offline. Okay, now, so now this is a program. You already downloaded everything. Okay. Now, let's assume this PLC have a HMI connected. Okay. Now I just do add. I remove this for example. Remove. Yes, normalize the run. So this program is already down transferred already, right?
Yes,
It's already inside the original program. So now this is the file I'm changing. Okay. Then I go and check in the settings. No, go to settings. Okay, now you close. If I just delete this, then I just download all those can no problem. Okay. Okay, let's say I go to settings and I just see what are the settings the programmer did. For example, okay. Then go to the building RS232. Okay. By mistake, you click this and you wanted to do some checking. You click here. Put this. Okay, for example, okay. Do checking everything, then you forget to go back to the original, right? Okay, close. So it means that is the port setting, the baud rate setting, the speed setting. Okay. So now, when you download, of course it won't give you any error. It won't tell you, hey, you already different. If you download all, it will download all. After you download all, then suddenly your HMI cannot communicate to the PLC. Then you don't know why suddenly. So you won't realize this one. What you do, you go and check the cable, you go and check the HMI port, everything. Why cannot communicate? Then what you think? Okay, the port is lost out. But actually the setting. Then later on only you will find okay. Check the setting. When you check the setting, different one. So now you don't know what is the previous setting. So you go back to the original file, the original backup. So that is the reason I tell you download separate. Okay, for example, okay. Now put back the one. Now go to settings. Change back to this. Okay, close. Okay. Now, let's say, okay, now different situation. Just now is we only change program, but when you download all, what happened? The HMI cannot communicate. Okay. Now the different situation. The different situation is now in the program I have a timer. By mistake I deleted. I didn't realize. Okay. But actually the thing is what I wanted to do is settings. You go to setting. Okay, go to building for example. Okay. Because why I want to do settings? Because earlier I used one HMI. Now I change to new model. So the new model, the baud rate 9600 is not enough. So what I do, click here, go to 19,200. For example, okay. So means I do setting in the, I do changes in the setting.
PC.
Settings, right? Okay. So if I want to download, I only download settings. Don't download the PLC. Why? Because just now I by mistake I deleted the timer. I didn't realize I deleted that.
Yeah.
But actually I wanted to do settings only. So after I download, your HMI can work ready. But when you press start, the motor keep on running. Cannot stop.
But the problem is your program is already changed.
No. Let's say
Yes,
let's
yeah.
say like earlier one didn't change.
Yeah.
By mistake you deleted whatever. So that is the reason. So that's the thing. Okay. That's why I said many situations. Okay. That's the first situation is, let's say this PLC have program. You already have the backup. This PLC now spoiled. You buy a new PLC. So when you want to transfer, you transfer everything. That is number one. Number two is, there's a PLC. You want to add a sensor. So you do wiring ready. You in the logic you check where you want to add a sensor. When you add, you just download the program because you only edit the program. Then there's another one. You add additional the option board. So when you add additional option board, it means it's in the settings. Correct? So you do some modification in the setting. You just download the setting. That's the three thing. So when it's completely new, you download all, no problem. Here you download all or you download a program only, no problem, not an issue because it's not connected to the machine. So when you work on machine, you must be careful. So it's very simple. My boss always say.
Why not just direct everything since you are changed? So everything will be not. It's not a good practice.
It's not a good practice if you ask me.
Because whatever you do here, you just put it inside there.
Yeah, that's why I say. That's why I say, okay. If I'm a programmer is different. The guy who do maintenance is different. Programmer, of course, he do from 0 to until you finish. So he will download everything. Now the maintenance guy will go do some changes. So it depends on where you change. Hardware or program. If you change hardware, download hardware. If you change program, download. Don't change, download all. Can, no problem, it's not an issue. But if you do mistakes, then you don't know how to solve.
Okay. I noticed that there are two scenarios. One scenario is that you already you transfer to the PC, you consider all the
From where to where?
PLC to
PC. Upload.
Consider all the
Upload, yes.
Why you call consider all the
Upload. You know why? Because I turn on.
also you use a PLC as a center.
Yes. Because PLC, you are the master.
PLC is a master.
No, you are the master.
I am the master.
Yes. So PLC, the PC, right? Okay. So PLC to PC, we call it upload. PC, this one we call it download. Because you are the master. So means you have all the data. Your PC is the user. Like the internet, right? You see, internet and PC. From the internet, you take what we call download, right? When you put something to the internet, we call upload. Correct?
Yeah.
When you put something in the internet, upload. When you take something from the internet, download. You know why? Because this is the master. Because who keep all the data? Internet. If you you want to use something, you download, right? So you are the user.
Okay.
Okay, you want to listen a song, you download the song. So you want to use the song. Okay? So if you want to save something, then you upload. So the internet will save for you. So all the data here, same thing here. So your PC will have all the programs. So let's say this PLC, okay, this program. So I upload. So normally these two terms normally we form.
Yeah, it's
People
like,
will-
confused.
People will confuse, yes.
That's
Because
why
you know why? This one still okay, Omron still okay, because Omron they don't use these names. Omron use a transfer to PLCs, transfer from PLC. Right. Okay, but you see like Mitsubishi they use read, write. Read the program, write the program. Okay. But like Bradley, Siemens, Schneider, Kiers, all that they use the term called upload down.
Omron also
Omron no, Omron transfer to PLC, transfer from PLC. Make it easier.
Yeah.
So they won't confuse. Okay, but normally what happen is since I'm teaching so many PLCs, I used to this term upload download. Okay. Actually very important. You know why? Because if you want to go to YouTube and search, you can search Omron PLC transfer from PLC. Omron upload, Omron download. Then only you can get what the data.
Your this example very good, easy to understand. That one is very confused, but this one is easy.
Yeah, I mean I just giving a comparison. Why? Why they call these names? Okay. This one change back to standard.
So that's why I said got two methods just now. Got two issues just now. Two issues which is when why transfer from the program or why partially transfer is when the program is new, it's a totally new. No, it's okay. As for example, they want to maintenance one for diagnostic machine because they don't know what happened. They will transfer everything to your machine.
Okay.
So they will write in the program, they will transfer everything back.
Yes. Correct.
Unless maintaining things they want to only work on the program, then maybe they could just copy the program in, do the program and read back. So they need to copy back the
Settings. Yes, correct.
Because their laptop did not have all the setting information. So
Yeah. Just program.
So that's why they just program. So
That-
it depends what scenario.
Yeah, it depends on where you change.
It's let's say for example you want to totally not sure about this machine, you transfer everything here.
Okay.
You will transfer also the setting here, right?
Yeah.
You just change it, then you transfer back. So
Not an issue.
no issue.
Yeah. That's the thing. That's very simple. You just download what changes you make. Very simple term means very simple term means just download where you change. You change hard settings, you change download settings. You change program, download program. That's all.
Understood. Yeah, something change. I do that standard.
Yeah.
Yeah. So I put a timer here.
T0.
T0.
Yes.
L.
Okay, double click. must put normally open or normally closed.
Normally open or normally closed. So this one is normally closed.
Yes.
No, normally
Close, normally close.
okay.
You download.
So save, right? Press save or
Save, work online and transfer.
Okay.
Okay, now you press the start button. Right? Escape first. Always escape use the mouse. Okay. Right click. Set on.
We can use a Control S on, right?
Yes, yes. Okay. Huh? So when I start motor on, okay, motor, then after the timer, okay. Go offline. Go offline, yes. Okay, these are the terms, like online, offline, download, upload, monitor, okay. What else? Input, output. These are the terms of PLCs. So if you want to go to Google or search everything, because you know why, this one is very important also. You know why? Sometimes I have seen some people, because I'm in the Facebook groups of PLC everything. I'm in their groups. So sometimes they share this some troubleshooting or that someone will have to face an issue. He post online, and someone will give the solution everything. Sometimes they say, okay, I try to upload, but I cannot upload. But actually, what he is doing is he try to download. So when you put a wrong term, so what they think, okay, he try to upload. So they will give they will answer based on upload only. They won't answer you in download. But how to do download? So sometimes I've seen that. So the terms is very important. So easy to search online because there's a lot of videos in YouTube. Even these PLCs, right, you can learn yourself. But the main thing is you need to have basic.
Yeah.
Because when you have basic, then only you know what to search. If you don't have basic, you know what to search. Because most of the things, if you ask me like 50 I learn in, okay, my boss teach me the basic things. Then I follow my boss. You do the training, okay, I follow, I see what he teach, everything. Okay. Then I also start to teach, do projects, everything. Then balance 50%, I learn from YouTube. So whenever I troubleshoot, because sometimes you don't know what to learn, right? You already know how to do the programming, but you don't know what to learn.
Yeah.
So what I do, whenever I face an issue, okay, I go to YouTube and then Facebook, all that, and then. The thing is, you need to know the keyword to search. If you know the keyword, then but the thing is, the keyword, then when you see the video, you need to understand what is that. For that, the basic training is needed. After that, it's all yours.
Yeah. Then yeah.
Correct.
Because I last time I tried to learn about PLC. I just go online and pick one of the device to learn because I thought PLC is same. So I think they have so many brands of Omron, Mitsubishi, there's no different device. So I just pick the one Siemens. I learn. I know that I learn about the different slot. Yes, I learned from online lah. And the tutorial, I buy the tutorial course.
Udemy.
I not finished.
Udemy.
Huh?
Udemy.
Yes, correct. I just learn quickly. Okay, we do that. And then okay, until I quite confused. yeah, until confused. Basically, like what you say, there's too many different brand of market. What I learned is just only one portion. I don't is can be used for others like or not. No,
But you can apply the concept.
yeah, but too many of software application was so not familiar how is operate.
Need to play. This PLC, after the training, if you get on PLC like that. You can if you also sell hardware and training kits everything.
You do?
Yeah, we have training kits everything. So you just get on PLC like that. And PLC also can. On PLC, then what? We have a laptop on PLC now. You don't need like all the sensors, only just a few push button, some input output enough. Then just play around software. Then small parts. Okay, let's say you want to learn about CC-Link. CC-Link, Mitsubishi easy to learn CC-Link because CC-Link is under Mitsubishi protocol. Then you will see, okay, CC-Link can connect to what? So let's say they say you can connect to an inverter. Okay, how much the inverter? Can we get inverter? Can I get a second inverter? Cannot. Any other device which is cheaper, but I can use CC-Link to communicate. Then you buy them. That's how you can learn. Okay. I mean, you want to put in not only programming but to troubleshoot.
I'm interested about okay. Maybe can get my answer and pray about that.
Okay. You just let me know what PLC you want. You can get some second-hand, new one only. Second-hand enough. There's a lot of, I know one company lah. It's a shop lot only. They selling all the second-hand PLCs. So what they do, they take they buy from the scrap. As company, they will scrap the machines, right? So there's one company, of course, they buy all this scrap material. So this company go and buy the PLC from refurbish, then sell. Most of my PLC are refurbished.
Oh yeah?
Yes. This one, the Mitsubishi, this two is a new lah.
Yeah.
This two new. Then the CP1E all new. But this one all refurbished last time because this one all new one cannot get. So last time when my boss started this company, he buy this the white color one he buy second hand. The CP1E, the NX series all new. NX expensive. One PLC is 3,000 plus. NX. This one is so expensive. New one, right?
How much?
This one is if I'm mistaken 1,500. Probably last time. Because last time I was training, so I had to. Then this Omron, and I also have some parts of this. Last time my brother going to Singapore, he brings some parts. The machine scraps, so
Actually,
he brings
the
some
whole
parts.
control box, the main one is PLC. This one, right? The rest is just
Just a relay, contactor, MCB, power supply.
Remember very common, right?
That one is very
That main is still PLC, the one is everything.
Yeah, main is the PLC lah, because of course normally because I do panel also. I do panel. Last time I do panels, PLC panels. So the main is power supply. Okay. No, the main is the main MCB lah. Okay. Because from the main power go to the MCB. From the MCB go to a few MCBs. Because one MCB for power supply, one MCB for transformer, one MCB for the PLC. Okay. Then actually I designed this also based on what? Later we use this to connect your PLC. Because I designed this based on panel also. This one the control panel. So you can put a PLC here. From the PLC, go to terminal block first. From the terminal block, only go to the field devices. This is field devices. So I designed this as a sorry. Only thing I don't have here is the MCB. Because normally when you connect power supply here, because all our PLC are all the IO is 24 volt. That's why I put LED 24. So I connect power supply, then go to power up the PLC, then from the PLC you put up the connector.
So for in-com, out-com.
It's the common for the input, common for the
ground.
It's ground, the common. Like you need to do later we do this one.
Okay. Very interesting. Actually, very interesting.
No, PLC very interesting.
Yeah, very
You
interesting.
know my because I'm not a PLC background also. I'm a mechanical background.
You may mechanical worker.
I come here and learn PLC. But the thing is, the advantage is I like to use computer. That is my advantage. I like to use computer.
Yeah, me like to.
Mm.
I like to.
Mm. So when you good in computer, I like to use computers all that. When you easy to learn all these softwares, then very easy to learn PLC.
Is that the rest?
Okay, yeah, you can.
For what time to attend? We should.
1 hour.
Yes. Okay. So I can come back here anytime.
Yeah, I can come back because I'll be here inside here. Because normally I bring food from my house.
Okay. So usually where's the shop nearby here?
Okay. You bring car, you drive right in. In front of the hotel there's a mama shop. Right, okay. But if you take this traffic light here, when you turn right, all the way when you go straight, on the left hand side you can see this apartment. After the apartment, there's on the left hand side, opposite of the apartment there's one tannery shop. Very nice, you can try that. Or just opposite of this gondola.
Okay.
Green field, opposite. But you need to U-turn. Hapiao restaurant. Yeah. Yes. Then when you pass the when you pass the condo, on the left hand side is like a few like workshops. End of the workshop is there's like hawker stores. Yeah. After that one. This area don't have. This area the mama shop and got a lot of foods, but like restaurants like Western restaurants like that. Thai restaurants, yeah.
I go there first. I need to go check with the hotel first.
Yeah, you can check then later tomorrow or you can try because 8 days you're going to be here.
Yeah.
You go round.
Okay. So I leave everything here.
Yeah, you can leave your
Yes, no problem. Okay, still one. this is coconut free.
Huh?
Coconut.
Oh, thank you.
I think only this year.
Oh.
Alright. No, I just try the timer. This actually, the 100 here is millisecond, right? Consider millisecond.
Yes, but it's not 100 milliseconds.
Oh, then what will the meaning?
Okay, 100 means 1 is equal to 100 milliseconds.
1 is equal to 100 milliseconds.
Yes. So this is what the timer is we call as a instruction, right? Timer we call as an instruction. Okay, so TIM 0 hashtag any value lah, right? Okay, so it means it become like this TIM 0 hashtag. So this is the timer number. Okay, then here is the value. The value is 1 is hashtag 1 is equal to 100 milliseconds. 1 is equal to 100 milliseconds. So if I want 10 seconds, so I key in 100. So it will become 10,000 milliseconds, which will be equal to 10 seconds. Okay? Okay, why? Because it shows this TIM is a BCD timer. Okay, what is BCD? Okay, BCD is a binary coded decimal, which is not a similar decimal, right? But it's not a decimal. Okay, CD.
But the original is default is 100 millisecond timer. That's the default by the system.
The timer, yes, is a 100 millisecond timer.
Even for others, the
Other brands,
yeah, other brands.
no. Mitsubishi same like this.
Only Mitsubishi.
Mitsubishi. Others different. Others you can key in 10 seconds. Others need to key. Others like LM is 1 equal to 1 millisecond. So if you want to key in, you need to key in 10,000. So depend on this one. And I will show you where to get these data. That is the most important thing.
Yes.
Okay. The first thing is, okay, I'll show you. We have decimal 0 to 9, then 10 to 19 and so on, right? Then we have a hexadecimal 0 to 9. I need to write 9. Then A to F. Here means it's a 15, right?
Yes.
Okay. Then continue with 10 to 19. So it means here 16 to 19. What is that? Hexadecimal 19. We go to calculator. I show you. Search calculator here. Yeah. You click here standard, change to programmer. Okay. Go to hexadecimal. Okay, key in 19. How much? 25, right?
Okay.
So 1A to 1M. It means 26 to 31. Okay. So this is the difference between this. BCD means, but if you go to Google, it will show up BCD means it's a binary coded decimal, binary convert to decimal, all that. Okay. The one is, you can understand, but it's a long explanation. Very simple explanation is, okay, BCD is actually is an hexadecimal number, but no alphabet. It means it will count with 0 to 9, then it won't take the A to F. Then 10 to 19. Means in BCD it's just like normal decimal number. But if you convert the BCD 10 into decimal, you will get 16. Okay? That is the difference. And in Omron, this one is very important, the BCD, because why? The counter, the timer, and later on the analog, we will see the BCD numbers. Okay?
But which normally they prefer to use decimal, SL, BCD.
Like this timer, I don't choose, I need to use BCD.
Okay.
Unless there's another timer, which is TIMX 0. Okay. In this case, this one also is this one is a binary timer. Okay, this is binary timer. This binary timer is there's two data. One is you can key in hashtag, or you can key in the and symbol. Okay, so it means if hashtag means this is in hexadecimal. This one is in the decimal number, binary. Yes. So it means here you put hashtag is BCD. It's a BCD here. In this case, this one is the BCD. Yes. In this case, in binary timer, if you put hashtag, it's a hexadecimal. You put and symbol, it's a decimal. Okay. How to know? This is the one. The toughest part is the numberings in PLC.
In what case you see this binary timer BCD?
Okay, I will show when I can use TIMX, when I can use TIM, right? What you do? You can close this calculator. Okay, go to help. Instruction reference CP1E. Yes. Okay. So you can search it. Index. Yeah. TIM. Okay. And double click TIM. Okay, you see they already give two. TIM means is a BCD timer. TIMX is a binary timer. Okay. So you see, if TIM, it is the data must be hashtag 0 until 999 in BCD mode. Right. Okay. If TIMX is if N symbol 0 to 65535, or if it is hashtag means 0 to FFFF in hexadecimal. Okay. So very simple here. They tell you that is a 100 millisecond units, right? So 1 is equal to 100 millisecond, right? So if I use here, so I can key 9999 means 999.9 seconds. But here means 6553 seconds maximum I can key. So one is 999 seconds, another one is a 6500 seconds. So it depends on which one you want to use. So when you need like a bigger values, you can go for this.
Oh, okay. Nice.
This is TMX. If just a 10 second, 20 second, then just go this. But just we need to remember that if TIM, hashtag. If TIMX, I can use 0, I mean the and symbol or the hashtag.
Either way,
Yes. Yes. Which one you prefer? But the number must be correct. The value must be accurate.
But how this is convert to second?
Yeah, 655. If you keep 65535 multiply 100 millisecond, then you will get, after you convert, you will get, because you see, if 100 means 10 second, right? Means like you deduct 1 0 lah, right? So it means the 655 65,000 means it's 6,500 seconds.
6,000. Yeah.
Just divide 10, you will get the seconds.
Divide that.
Yeah.
Then it will be 65.
Because you see, one is then 100 means it's 10 seconds, right? So if 100 divide 10, you will get 10 seconds. So if 6,000, 65,000 divide 10, you will get 6,500 seconds.
100 divide by that.
No, wait. Okay. See, 1 is equal to 100 milliseconds. So if I key 100 means, it's a 10,000 milliseconds, which is equal to 10 seconds.
Yes.
It means whatever value you key in, just take out the last one is the second. Right?
Okay.
So if I key in 65535, it means 6,500 seconds.
6,000.
Yes.
Right. So take out 110.
Yeah, the last one lah.
Last one.
One number, yes.
It's more higher. It's more higher second. More second.
Yeah, no seconds. So depend lah, because this one is 999 seconds only maximum. If you use this lah, right, BCD, because if you take the last one, it's a let's say like 1,000 seconds lah, right? So 1,000 seconds, this one is a 6,500 seconds. So which is the more. Okay, good. So it's depend on them. So many timers, actually you click here, TIMH. This one is 10 milliseconds. It means 1 is equal to 10 milliseconds, which is smaller somehow. If you want 10 seconds, you need to key 1,000. Then TIML. Go to TIML. This one is a long timer, which is 1 equal to 0.1 second, which is similar to, actually similar to this lah, right? Because 100 millisecond is equal to 0.1 second. Similar, but this one can go bigger numbers. Okay, later I will tell you what number all this. Because now you see this one, you won't understand what number is.
Yeah.
Later, once we see the data types, all then you can understand what is this mean. Word, double word, integer, double integer, all that. Okay, good. Okay, close. So anything you want to know, you can get it from here. Okay. Now,
This one.
can leave it. Okay. So now what we do? Now we do some wiring. We will connect this, do some wiring, some input output. So easy to test later. So want to do some small project, easy to test. Okay. Okay. Never mind. Is it connected to Wi-Fi, right?
Yes.
What you do, you can go to Google. I will show you what is how to know about your hardware.
Hardware.
Your hardware.
Hardware.
Yes. So you go to your CP1E hardware manual. Search for CP1E hardware manual. Hardware user. This is Mitsubishi software user unit introduction manual. I think you can click here first. Click here. Introduction. Go down. No, sorry. Slowly. Go down. Go to next page. I think you click here. Just click here. Yeah, just click the right arrow. No. Just click here. And then right arrow.
Because this one is not in PDF, it's online, that's why.
Yeah. Okay, now just scroll first. Go down. I want to see the table content.
Table content.
Okay. Part number and function. Okay. So this is the one. You can download this. Yes, you can download, keep in your file or some Omron manuals or something. Okay. What?
Sorry.
I think where you see downloads. It's not. No, just now I think you click this PC. Okay, you make it smaller. Okay. Now, this one can I go to the course content? I mean the content. Can I go to the content part? Thank you. Part name and functions. Okay, click. Go down. No. I think it better click here. Go down. Click here. Okay. 3. Yes. Okay. Click the 3 point. No. Go up. I just click here to bring to the page. Okay. Now, this one is the CPU models. Okay. So you can see here. You can see, right? So we have CP1E, E10 or E14 or 20 and N14, 20. So this is okay. Go down. Okay. Because you see the E don't have the RS232 port. The E N is come with the port. So that is the difference. E without the RS232, N with the RS232. Okay? Go down. Manually. Okay, go down. Scroll down. Go down. This one about the lamp, everything, the wiring, everything. Okay, this one is for the E30 and on. Okay. So starting from E30, you can add expansion. Okay. Here also same. the expansion can add for N30, 40, 60 or NA20. You can add the expansion. Okay. Go down. The one VF is this one. HCP.
Yes.
CP1N.
Where is my
No, I think this one, not mistaken, is a mistake here. It's supposed to be CP1E. There's no N.
Yeah, this is exactly this.
Yes, it's a mistake here. Supposed to be CP. Can I have go down? There's no CP1N. Okay, go down. This is how to do the wiring and everything. Okay, go down. Okay, wait, go up. Go up. Okay, see. Ours is what? CP1E
And 40.
and 40.
And 40 DS. And 40 SDR. That's A.
SDR.
Yeah.
Okay, go up. DR. Okay. Go down. R the next, maybe in the next one. Okay. Common IO. Because R means is a relay output. Okay. So now you know the N means is what, R means is what. Okay. The PLC types now. Okay. So here. So CP1 and 30 D R dash A, right?
No. S.
Yours
SDR.
S, the S I don't care. Okay. S is just a type because there's some additional functions. That's all. Okay. So for these the N for N they have N and also E. Okay. Okay. So if you see the N and E, what's the difference? You go up. Go to and go up some more. Slowly go up. Stop until you see the PLCs. Okay. You see the difference between E and N. E don't have RS232. Can you see? This is a CP1 E30, E30, 40, 60. All is no RS232. Can you see? But when you see N, come with the RS232, whether here or here. Okay? So, see, N is what RS232. E is no RS232. That's all. Okay? Then 30. This one is, we have 30, 40, actually got start from 40 also. Then got 20, 30, 40, 60. This is the number of IO. Okay. Then the S, we don't care. S is like a special function area. Okay. Because see, S they have like a building N30. Ours is the S, right?
S. Yes. S.
And 40 SDR. Because N40S, right? S is here. N40S. Okay, here don't have this one. Because this one S1 means you have a building 4854.
Building RS
485.
485.
Yes.
What is 485?
485 485 is a communication. This one. This PLC. You can take that PLC. You use this one. You can take this PLC. No, this one. You use this one. This one.
Sorry, which one? Oh,
This one. Okay. You take out this.
can take out one.
No. Down here.
Oh.
The below one. Open. Push down. Yes. Yeah. Yes. Correct. Sama. Okay. Yes. 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 Take out.
Take out.
Yes.
Okay.
Yep. You see, both are same, right?
Yes.
I think so. Just this one. So this one is the N40 S1. This is S. So when the S, no RS485. The S1 will have a RS485 port. This is where we can use the communications like Modbus or that. We can use it. Okay. Maybe I think we can shift from here to here. Yeah. No need to use it later because once we do the wiring again, want to change.
So I think this one considered as a Modbus.
Yes, for Modbus you can use RS485.
But this original port is like that.
Yeah.
Original port.
No. This one I put. But every time need to connect here, this one port will spoil. That's why I put it here, so where we can connect here.
Can take out.
Which one? Can take out. Just remove the first cable only. Remove the first cable.
Oh, like that only.
Oh,
this one actually built-in one.
Yeah, this one is a built-in one.
This one considered as RS 485.
Yes, 485. Okay. Then this D, right? Okay. D because it's a DC input. If you see all D only. You see, all D only, right?
Yes.
D. So it's a DC input, okay? Then the R. R is okay, you have for R T1. Okay, it's not showing here. This is the output. Okay, this is the relay output. Okay, this two is a transistor. Transistor output, both are. Transistor output is a DC output lah. Okay. But what is T? Next, go down. Go down. You stop when you see like the table like just now. Okay, wait here. This one is okay. Go down. This is a relay output. Okay, go down. Okay, transistor output, yes. Sinking or source sync. Okay, wait where it shows sync output or source output. Syncing output module, okay. Go down. Go up. Okay, go down. Go down. This one is an analog. Go down. Okay, go up. Go up some more because for T and T1 there's a different issues. Okay, here. put on. It's just, yeah.
This one.
Here.
Okay.
The one I want to order. So E is a basic model, application model, and A is a application with built-in and lock. Yeah. The and lock. There's another one called NA. Then S you will start S start is a with built-in RS-485. Renew this one run is renewable type. I'm not sure. DC. Output is R relay output, transistor output, syncing, sourcing. Okay, this is what I wanted. Because I always confuse which one is sync, which one is the source. Okay. So transistor syncing, right? It means you see, our output is 0 DC. Syncing. T1 is a transistor, which is this one we call sourcing is 24 VDC the output.
Sourcing is the sourcing is 24.
24.
Syncing is 0.
Then the last one is a power supply. A is 230 AC. D is a 24 DC. So from the part number you know already. Or when you want to buy, you must follow this. What model, what application do you want to use 485? Do you want analog? All that.
A is power supply. Power supply A is
The last one is the main power supply to power up the module. Whether it's a, yes, AC or DC.
So this one AC.
AC, yes.
Got DC one.
Yeah, DC. I think this one is DC. if I'm not mistaken. You see here? Is it DC here? Plus minus.
Power, yes, DC. 24. AC. In what condition will you AC? In what condition will you DC? Don't know. Yeah.
There's no condition.
No condition for condition.
But if you want to protect your PLC, you can use DC.
DC.
Why? No, because if something short, right? Because AC normally we take direct, right? Direct AC current, correct?
Correct.
Okay, like this was for example. If let's say this plug is short, what happens? Let's say this plug short. Trip, right? Trip, and sometimes it can damage your PLC.
Correct.
Correct. If I use DC means I need to use a power supply like this. So AC convert to DC.
Yeah.
So if something happen, this one and this one,
Yeah.
your DC will. That's the difference.
Just an AC converter.
Yeah, AC to DC. But normally we call it a power supply. Power supply.
Power supply.
Okay, good. So this is the data we get. Whatever data, everything we can get from here.
But when you come to do a project, there's many things to consider, right?
Yeah, correct.
Sometimes if you not prepare the port, then at the end,
Yes, because correct. Because let's say lah, I want to use RS485, but I buy the S model only. I didn't buy the S1.
Yeah.
Then finish. Need to add additional module for that. Need to buy the additional like this lah. The option board. Need to buy the additional option board for
Sure.
Yes. That's why whenever you need to buy, you need to make sure about the project. Okay, how many I/O, that is normal lah. Okay, how many I/O, what communication are you using, all that you need to know. This one, all PLC are same like this. You can get the data from the hardware. This is a hardware manual. Yes. Okay, good. You go down. You just scroll down. See what any other things. Okay. So here it will show for each part number we have everything, all the data. How many input, how many output, AC, relay type, 2K step, everything. So from here itself we can decide really what type of PLC you want to use. Because this is the lowest one, E10. 6 input, 4 outputs. Very simple programming. Just let's say you have only 4 output only, you can use this. For training all can use that.
The maximum will be how many?
60.
60.
Maximum is 60. 36 input, 24. Okay, go down.
For us, I think usually we buy the largest one.
Yeah.
60. But cost also expensive.
Yeah, of course. Because even S and S1 also there's a difference. Because built-in R485, okay, option. This one is option products. Yes, this is the option board for the. So you have a RS232, you have a 485. But two type. One is non-isolated, one is isolated. Okay. Then Ethernet option board. I have also. I have this one. I have Ethernet option. I have analog. Okay, go down. Analog input output, and they will tell you which model can use this. Can see. Mounted option only available in N30, 40, 60 or N820. Others all cannot.
What is the analog input option? This one?
Yes, it's the analog.
This one?
Analog option board.
Okay.
Later we use that.
It look like RS485. It look like option.
Yeah. I mean, they use the same type of board lah. Okay, go down. Then battery. Okay, you see, that's good. Okay. You see the battery function is what is the function. Okay. You mount the battery to, okay, you need, if the data in the following areas need to be retained after the power instruction. So you see, DM area, the data register, like I said, right, the battery can keep. Holding area, counter, auxiliary area. So these areas, so it means it's not the program, it's not your logic. If you keep the value, so logic will be there. Don't need to worry about logic, okay? Then, okay, go down. Okay, go down. This one is a version. Go down. Okay. Then says programmer lah, what version you can use. Okay, that's all.
Here convention version.
Alright.
Version 1 by 1. Version 1.
So no,
This one is a old one.
not this one is our PLC one. Okay, go down. Okay, yours is CP1E. Go down. Go up. This one is CP1E. Go to CP1. Oh, sorry. Okay, so ours is CP1E 40 version or earlier functions. Okay, all these CX programmer version can use. So if my version, because mine is 1.1, right, means all this version can use that. If let's say mine is 1.3, only version 9.6 only can use.
This version is the software.
This is the software, the CX programmer version.
Now we are on what version?
9.7. 9.7 means you can use all the versions. Okay. Alright. Good. I think that's all after that. Okay. This one, okay, good. The total up to 3 CP series expansion can be connected. You see, CP1E, the 10, 14, 20 IO cannot add the expansion, the additional modules, okay? Starting from E30, 40, 60 or N30, 40, 60 or NA20 can add up to 3 modules. So let's say more IO. So you calculate the IO, let's say, or because you see the 60 IO one, you have 36 input, then 24 output, right? Okay. Want to add more? Okay. Go down.
4 set.
No, maximum 3 only.
Yeah. One original.
Original one. Okay, we don't care.
We don't care.
No, original one is the PLC one. Later one to add is maximum 16 input only.
16 only?
Yes.
Not 60.
No.
No. I mean, let's say we compare for the 61. The one.
Okay. This is the 60 IO. So this is the CP1E and 60.
60, yes.
Then you want to add this different. Okay, go down. See what number. Okay. No. Go down. Okay, you see. Got 8 input, 16 input. Go down. Maximum is how much? 32 output.
14.
This one only 32 output. This one is 20 IO. Is a input output. 8 relay, 12 input. Okay. So 40 IO is 24 input, 16. This is the biggest one. Go down some
24, 16.
24 input, 16 outputs. Okay, go down. Okay, that's the maximum. Okay. So let's say 24 DI, 24 DI, 16. So this is the maximum you can.
Total how much?
How much? So 36 plus this one is 16, 84, 106, right? 60, 84, then okay, 108. Then is a 24, this one is a 40, 56, 70. So we need to correct. So maximum. If more than this, what I do?
More than that. Total is 180.
But let's say more than this already, what I do? I
Buy another PLC.
buy the CJ.
CJ.
Yes, CJ series.
Why?
CJ series,
Can add no matter how many.
CJ is using a modular net. Correct. Okay. So CJ series, if not mistaken, they have
No limitation.
64 one card, 64 inputs. Can have 64 in one card.
One card 64, now it's 40. Okay, but can it out to how many?
That one I'm not sure. That one need to check the CJ manual. But that one can, and also can use like this lah. For example, see, this is a CJ series. What you right? Then you can add. This one is a device net. Device net you can add here. Then you can add additional IOs. So device net is like a additional remote terminal. So this one will connect here. Then this one connect to this. So who control this mod? This output OD ID. So this input output who control? This PLC control. So can go, the CJ series can go up to 1000 IOs.
What you call this also?
Device net.
Device net. Why not just contact?
Direct cannot.
Cannot.
You mean this one?
I mean the IO.
This. This two cannot. Because this one is a remote terminal, is a device net remote terminal. So there's no connection to connect to here, because I need to use this to connect. So this one I need to add here. From here, then I connect to this.
Until the output is at full, only add on this one device
Not
net.
necessary.
No.
Necessary, because this is like in the main panel.
Yeah.
This is some other panels.
Okay.
Then this one you connect here. Then you buy one 5-core cable from this panel to that panel. You take the 5-core.
So this one is with
Yeah,
the main
must be
one.
there.
With
In
the
the
main
main
one.
one is
So
this
this one another side panel.
Another side panel, this one.
But this one is only out to 15 out
16 lah.
16 lah. Not many, no?
No, that one I need to check. Maximum how much they have.
It's a remote
Should
terminal.
be 16 lah maximum.
The device net.
Mm.
Okay.
So many models.
Yes.
Yes.
Many model.
So when you study about PLC, actually 8 days is not enough.
Yeah, I know.
Yeah, because okay, good. Now, okay, this one can minimize. Now we do some wiring. Okay. Okay, can I increase this?
Okay.
Yeah. Are you familiar with wirings?
I know on practical.
Okay. See, for PLC, just the DC enough, right? DC wirings. Wait. So the program inside the program, right? Actually, you need to change because both are same. Because you only select until the N40 only. You won't select S1 or something. Yes. So we use this one. So later we can test the 485. So already one time we test the 485 to check the numbers. Can use the 4, but the 5th day lah. Can use the 485. I have one inverter. Can just try one inverter. Just like this zero.
This one right.
Yeah.
This one. This one bit common.
Earth. Grounding. Okay, now actually you can take this properly.
The top one is all the earth, right?
What is it? No what?
That part is all the earth.
DI.
Earth.
It's a DE input. Digital input.
This one here.
Yeah.
This one is okay.
Neutral.
Light.
Yes. Now what we do? You see 24 VDC, right? Okay, for this 24 VDC, actually this one also got power supply. Okay, there's a, can you see DC output? Okay, so you can use this DC output plus minus. Okay, so this one is the top one. This one is the top one. This is the bottom one. Okay, so you can take one positive. Can connect here, so all these three are connected. Okay, I use this one to connect all these three. If no means it's like one by one only to be lost. Okay, then you take one negative, connect here 0 volt and 24.
Okay. So plus to here.
Yes. So you can get the minus go here.
Minus
Any of these three.
only we play around this way only.
Yes. These three. Anything. So if you connect here, all these become 0 volt.
Okay.
If you connect positive here, all these become positive.
I see.
So later wherever you want to use positive, you can take from here.
Okay.
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 Then this input common is the, from here I go to all the switches.
Okay.
Okay. Then one by one I go here. Input 1, 2, 3, 4, 5, 6. Yes. And from I already connected this part, right? Now you from here you can connect to the 0, 1, 2, 3, 4, 5.
Okay.
Okay? Okay. Then you can decide the input you want to connect 0 volt or 24. I will do the wiring diagram. Can you understand? Okay? Same. The output is same. So these two will take the signal from the power supply. These two is won't be connected here. So it depends on how you want to connect the wiring. Okay? This output is the same. I take from the power supply, I connect here, then I go to the all of the lamps, right? Then one by one lamp connected here. Then from here I connect the 0, 1, 2, 3, 4, 5. So can you see output got a few comms, only input only one comm.
Yes.
Okay. So this comm, this is the common for the input. Very simple. If the common is 0 volt, my input must be 24 volt. So means if this is this one here I need to connect 24 volt. So means the 0 volt will go here, direct. The 24 volt will go here, go to the switch. From the switch I come here. Then I go back here. Yes. So means the 0 will stand by here, the 24 will go to the 1. Then number 1 will activate. Okay?
So means that this supposed one is actually positive from here, not from here, right?
Can. Here also can.
Can here to here.
Yes.
Here to here also can.
Can, yes. All same only.
Yeah, also.
But here means just need a small cable in. Yes. Okay? Output also same. Output, because this is a relay type, right? It's a R, correct or not? Where is it? It's a relay type, R. Okay? Yes. So it means relay means very simple. Whatever I connect at the COM, that will be my output. Let's say at the COM I connect 24 volt, my output will be 24. If I at the COM I connect 230 volt, my output will be 230 volt.
This one is plus minus, right? Plus minus.
Plus minus, yes.
So this one will be
COM 0, yes.
So plus 0,
24. Then here, when the output on, here we get to 24. Okay? Because relay type means it's like a winding relay. This is their contact. I can normally open contact.
This one output connect to
Here.
here.
Yes. Okay, you see, very simple. Let's say we take at the COM we connect 24 volt. Means take 24 volt, connect to the COM. Okay? Then once this one activate, the 0 I connect here. Okay? Then means is here I will get a 24 volt, right? So 24 volt, then 24 volt will go to the first line.
Correct.
So is this side. So this side what I need to connect? This side is 24 volt, the other side must be 0, right? So the 0 I is output COM. If this COM is 24 volt, this output COM must be 0 volt. If this COM is 24 volt, this COM is 0 volt.
24, this one must be
0, yes. If this one is a 0, this one must be 24. Opposite way. It means I give 0 volt here. Means when the output is energized, the 0 volt goes to this terminal block. From this terminal block, go to the left. So the common must be 24 volt. So the common is looped and connected. Okay? Okay?
This will be a ground.
Not ground, common. Don't confuse with ground. Ground is different. Don't confuse. I know sometimes they will tell the 0 volt is a ground. Don't confuse with them. Ground is different. 0 volt is different.
So ground considered this one is a ground. Technically is a ground.
No, not necessarily. Not necessarily. As I say, no. Because I know, because sometimes what happens, sometimes the 0 volt, let's say this power supply 0 volt, right? They will, let's say this ground, when you attach to a panel, when you, of course, in the panel they will have a nut for the grounding. Then they take this 0 volt also connect to the grounding because they want to avoid what I forget short when you touch or something. That's where okay. Then this 0 volt is grounded, so we can call ground. Now this 0 volt here, I didn't ground here, so don't. It's not a ground yet.
So it's not grounded, then what will be?
It's just positive, negative only.
Positive, negative.
Yes.
Light, neutral.
Yes, but not light neutral. Light neutral for AC.
Power.
AC we use light neutral light. For DC we use a DC 24 0.
So is not
necessary must be 0 can, 24 can, 230 can, because it's a relay type. If it is a T, then it's a sinking. Then the com must be 0.
Oh, okay. Now this one is sinking.
R.
Now is
Relay type, right?
relay type will be.
The com can be anything.
Oh, electric is the
T.
the T.
T means the com must be 0.
The T com will be 0.
Yes. If T1, the com must be 24.
24. Then how about this one?
Output will be 24.
Always will be 24.
Yes, always is a fixed.
This both is a connect.
No, not both connect. One at a com only you connect. The 0, from the 0 you will get from the PLC.
Get from PLC.
Yes.
Okay. So usually this the top one only the connect wire, right?
No, must connect both.
Sorry.
Okay. The com must connect from the power supply.
Mm-hmm.
The numbers, right, must connect to the my output devices.
Station.
Yes. Same, here also same. The com must connect to the power supply.
Power supply.
Always. When you see com, right, this right, always must from the power supply. You cannot connect to the device. The numbers you see, that is the one going to your device. Like a push button, selector switch, lamp, contactor, whatever. Okay?
How about the com here?
This com is the same.
The com also be.
This com can be 0, can be 24.
Mm-hmm.
So I will draw the wiring diagram, then you can understand better. Okay?
Interesting.
Yes. Wiring. But the thing, that's the thing, anything you want to learn, a few times you do, then you can draw already.
Yeah.
Because wiring diagram last time I do panels.
I always see that they do quite easily.
You know, okay, there's a difference. There's a difference between those who do wiring, refer to wiring diagram. Because they just refer to wiring diagram. If sometimes you ask them how it works, then sometimes they don't know also.
Yeah.
Those who design wiring diagram, they must know all this.
Then I ask you, usually for this PLC programmer, they're the one who do the wiring. No. Then the wiring
Is
is
a different
another
type.
person.
Yes.
They do wiring.
The wiring also, who do wiring? Actually, if we let's say we talk about big projects.
Yeah.
Okay. So one guy will do the wiring diagram. After wiring diagram, okay, this data sent to the wiring team. They will do the wiring. Okay. Then one guy will design the program based on the flow chart, everything is given to him. He do the program. Once he do the program, then he will pass the file to another guy. These guys are going to do the commissioning. Then this programmer go to the other place for the.
So the first one will be the electric diagram first.
Yes.
Come up to electric diagram and then flow chart and then pass to the PLC side. PLC side will do the program.
At the same time, the wiring diagram is passed to the electrical team. They do the wiring. They build the panel.
That's why I saw my team. They do the program. They do the wiring themselves.
It means okay, actually it's good. Those who know how to do wiring, how to do program, how to do the instruments, set up the instruments, they they are more powerful. You know why? They can troubleshoot anything. When they want to troubleshoot, they know if they can troubleshoot in the program, they can troubleshoot the wiring diagram, they can troubleshoot the instruments. Because sometimes they don't know what. Not necessarily must be if of course you need the basic knowledge of wiring if you want to do programming.
Correct.
But not necessarily you need to do wiring.
Like for example, they do the wiring program, right? Because definitely they need to know how to connect all these PLC.
Yes.
Otherwise, cannot.
Yeah, of course the device won't work, but it won't affect your program work. That's why I say programmer can be different. That's why sometimes some company they take freelance programmers. They just hire a programmer. They come and just do the program. That's all. They won't involve in the wiring.
You design for the wiring also.
Yeah.
What kind of software do you require? Any software?
Yes, there's a most common one is the E-plan.
E-plan.
Yes, E-plan software where you can design the wiring, or you can even AutoCAD also can use to do the wiring.
E-plan. Which better to use?
E-plan.
Better 5 check for me.
What the software?
E-plan.
I have the software, but I don't know whether it's the correct version.
Interesting.
Okay, good. Now we see the wiring. Now the input part I see. Okay, input what we have? We have COM, right? Then the 0, 1, 2, 3. I just put until 3 lah. But you connect all the 6. Okay, see. We have a power supply terminal block. Correct or not? There's a terminal block for power supply.
Yes.
The 3. No. The terminal blocks. Yes.
Yeah.
That is what we call the power supply terminal block.
Yeah.
Positive, negative. Okay. Now, from the power supply terminal block, you take one cable, connect to the COM. Okay? But is it a positive 24 or 0 volt? Later we see. Okay? Then each of your output you connect to the one terminal block, right? The output terminal block.
Yeah.
Okay? And these terminal blocks are connected to a switch, right?
Yes.
Okay. And each switch already looped, right? All the switches are looped, right?
Yeah.
Then I connected to a terminal block that's called in COM. Okay? You see, and there's two COM here. This one we call is the input command. This is my switch command. Then this command also need to connect to the power supply. Okay? Good? Okay. Very, very simple. If this COM is 0 volt, easy. It means I stand by 0 volt.
Yeah.
So here I need to give
Positive.
24 volt.
Yeah.
Because why? How the PLC work? Inside here, the PLC they have a optocoupler. It's like a diode.
Okay.
So if you connect 0 here, if you connect 24, this one will activate. This is the one send the signal to the CPU. Input number 1 is on, 1 or 0. Okay. So this one must be 24 VDC. If the COM you connect 24 VDC, the input COM, the loop cable must be 0 VDC. That's all. Okay? So if 24 VDC, we call it as a source or PNP. Because why? The input is a 24 volt. So it's a PNP sensors.
Yeah, there's a lot of people say this is PNP or NPN. So
Yes.
sometimes I'm quite confused. So which supposed to be?
Yes, very simple. NPN is PNP. You see PNP, I put 24 volt. NPN is 0, right? Okay, so you see PNP and NPN sensor. Okay, normally these sensors how many cables they have? Only we have 3 cables. Okay, proximity sensors. Some is 2 cable. The 2 cable means is that this is a dry contact. Okay, it just take the signal from the power supply, send to the PLC. Okay, that's all. The 3 one is you need to add additional power supply. This one will have a 3 color: brown, blue, black, right?
Yes.
Brown, blue.
Black is the earth.
No, black is the signal.
Signal.
Yes. Brown is the positive, 24 VDC. Blue is the 0 volt DC. Black is the signal.
Oh.
Okay, so it's the same. 24 VDC, 0 VDC. This one is the signal. Now, you see, this is a PNP, right? So the signal will be 24 VDC. Means the signal is the one input. So, see, your input is 24, right? That means you must use PNP sensors. Okay? Then here, this is the NPN. Just take the last number that is zero. NPN means is a 0 volt DC.
When the signal is 24 volt, it will be PNP. When the signal is 0, it's an
Yeah, when the signal is 0 means it's an NPN.
So when come to design, how do I know that
Whether want to use PNP or
Yes.
NPN.
Yes, I
But normally Omron they use NPN.
Omron using NPN.
Yes, Omron, Mitsubishi, Japanese PLC lah. They use NPN. Europe, like Allen Bradley, Siemens, all they use a PNP.
Mitsubishi, Omron using
Mitsubishi,
NPN.
Omron, the Panasonic, Siemens, all that is NPN.
And so that's why when we buy the PLC, we need to know this is NPN.
No, input no problem, because input both also can. It depends on what you connect at the COM. If at the COM you connect 0 volt, means your input must be 24, right? So it's a PNP sensor. If the COM you connect 24, the input must be 0 volt, it's an NPN sensor. So both way can, but only one lah at the time can use. Because you see, for input only one common.
Thanks for the patient. Thanks for the patient.
No problem. This is how I teach all this.
You're very patient. Very teaching. Very good teacher. So when the means that when they buy the components, choose the NPN type. Alright.
Got ya, common lah for Omron, common.
That's why I go buy the NPN.
Yes, Omron, most Japanese PLC lah mostly.
So not the PLC to buy the PLC type of NPN. It's the component that sensor things by the NPN type.
Yes, correct. Not the PLC.
That's why I'm so confused.
Because PLC can accept both NPN or PNP.
But here you got the type of model for transistor.
That is the output.
Output.
Because sensors are inputs.
Sensor are input.
Right.
Sensor are input.
Mm.
Sensor input.
Yes. Sensors are all inputs.
Okay.
So, because normally when you buy sensors, for only sensor you will choose like NPN or PNP, not the outputs. So output is the one that just now we see is a transistor, right?
Yeah.
T1 and T,
Yeah.
sink or source.
Yeah.
So for that, it depend on your device. What device I want to control. The PLC want to control one device. If let's say I have a device, let's say to on the device or to operate the device, I need to give 24 volt DC.
Okay.
For example, so I can buy T1, transistor 1.
Yeah.
Okay. Let's say the device I must give 0 volt to control, so I must use the T.
0 as a source. 0 as a positive side.
No, 0 is the signal to the device. Okay. Then if let's say the device I must give 230 volt or 24 DC or any I can use a relay type.
Okay.
Relay type
For
for 230 volt
or
AC
0.
or 0 or 24. Okay. Okay. Normally the transistor is special case. Relay for all can use. Okay, but for transistor special case it means, let's say your PLC want to control want to give a pulse output to any device. So it can be a stepper driver, can be a servo driver. So stepper driver, servo driver need pulse signal. So if the pulse signal, only transistor able to give pulse signals, relay cannot. So in that case I cannot use relay.
Relay just
Yes, on off. So there will be a delay, right? Transistor means inside there's a built-in transistor, so it can control the on off can control. So can create pulse outputs. Relay cannot create pulse outputs. Okay, so now the transistor got two types. One is the 0 volt, one is the 24. Then it depends. Let's say your stepper. Let's say the stepper driver is controlled by 0 volt pulse. Then I use the. Let's say the stepper is 24 volt pulse. Then I use T1.
So means that the plus minus you don't need to bother. Always have a plus and minus for this is why.
Yes.
But just only the signal you just need the whether you want the 0 one or whether you want the positive one.
Yes.
Now I understand now. So means that you need to buy the pulse signal is always the black color.
No, it's not here.
It's not here.
Nothing to do. This one all input. Just now I talk about outputs.
Output what will be the color will be for the
No colors.
no color. But they still need the positive and negative one. Just only the signal one that I guess is the
Yeah, of course, that is the device. We talk about the device.
talk about the device.
At the device, of course, you need to give the power, everything. So for the device, you need to give it's something like for the device is the input. So it's same. I know what you mean. The same like this lah. So it can be any color, no problem. There's no colors.
Usually for the motor we'll be using that type of this type of transistor.
Yes. Like stepper or servo drivers. Must use a transistor outputs.
So now I understand now. I think the easier way to buy the relay kind of PLC. It's not a transistor.
It's depend on the usage lah, right? It's like a heavy usage means you just going to on off a relay, contactors, blah blah blah. That is the relay because relay type each terminal I think minimum how much you can see that there's an M can pass through the terminals. You see output AC, right? input is 24 DC finish, right? Okay. Output is a 24 DC also can, or 240 AC also can. Okay. 2 amp per coin. Okay. 4 amp per com. 20 amp for unit. Okay. It means per terminal, per point can take 2 amp maximum. That is going past through lah. Per com means it's a 4 amp. So this com is only for this. Okay, like this com for this 2. Right. This com is 1, 2, 3, 4. You can see the thick line. You see thick line? Yes. If you want to use this, you need to connect this com. If you want to use number 1, you need to connect this com. Want to use 2 and 3, you need to connect this com. So like this com, how many? 1, 2, 3, 4. So maximum for all these maximum is 4 amp only. For one com. So 2 amp per coin.
2 amp per coin.
Yes. 4 amp per com.
What is the mean actually? Coin.
Com means okay. Maximum 1. If I am using this lah, 1 maximum 2 amp lah. But in this case, right, total for this maximum 4 amp only can. But if you are using only 1, let's say only 1 only 1 can go up to 2 amp. If I am using all the 4, maximum 4 amp only. Ampere. The ampere can pass through. Because relay means this is their contacts actually, normally open contacts. Then total 20 amp per unit. If let's say all the output on, if you measure all the output, maximum 20 amp ampere. Yes. In DC don't have that. In DC. Okay, this is a D. That's one. Sorry, T. DT, right? Transistor output. Okay. So can you see output 30 DC.
VTC, correct?
Okay. So per 0.3 amp per point, 0.9 amp per com, 2.7 amp per unit.
Okay.
For DC lah.
Not many.
Not high.
Not high.
Yes, it's because normally it's a DC only one. So controlling a small device. I mean,
so meaning that this device only can support up to 20 ampere only lah.
the whole thing,
The whole thing.
the whole output you calculate.
More than that we burn. So we cannot supply more than 20 amp, or they cannot.
Yes, I mean the device I control through this PLC. If all on at the same time, it cannot be 20 amps.
If some device more than 20 amp will be.
What's it?
Have to add on additional things.
No. Okay, what I mean is, if output right here, for example, okay, let's say we have there's one com, right?
Yeah.
Com for 0, 0, right? Okay. And there's another com for number 1. Okay. Let's say this is my instrument. Okay. I connect neutral here, then the live goes here, then come and connect here. Correct? This is how it works. Very straightforward. Okay. So this from the power supply, the neutral directly go, the live will go through the com. When the output is on, I connect here. Okay. Same thing here also. The neutral I connect here, then the line I connect here, I connect here. Okay. Okay, let's see. This is one terminal. It means this one terminal can bring 2 amp of current. Means this one maximum must be 2 amp. If it is more than 2 amp, if it is overload, what happens? Because sometimes this one, of course any device they say 2 amps means, of course, it won't take 2 amps. It just take a few amps to operate. But let's say if it is overload, then it can take more current. So when it take more current, when it pass through the more currents here, then this terminal will spoil. The same thing, if you have all these connected to this one, if all working at the maximum capacity, then maximum capacity means I am. So if you calculate all these amps, let's say more than 20, then you damage your outputs. Same things for normally the transistor is the one always spoiled, because just a transistor you see how many amps. One point is just a 0.3 amps. So what happened? Sometimes more than 0.3 amps, the particular terminal will burn. So you can't use it. So you must use the other terminals. So that's why better if normal like a normal control, just use the relay type. When you require to use like high speed control like a pulse, then you can use a transistor. If no, just on off, can use the relay. What is the relay can last.
Okay, I try to do now.
Yes. Some cables there. They are all reuse cables. So it's very simple. You decide first. First we do input, then we do first. So you decide first whether you want to use NPN and PNP. According to that, just take and connect here. Then you connect all the 6 inputs. Which is input. You see like up down. So you do that.
I want to ask you, COM and one, which one would prefer to you? If this one would be connected to the device or
No, this one is the device. Always the number is the device.
Number is the device.
COM is from the power supply.
From the power supply.
Yes.
Okay, power supply.
Yes. COM is the power supply. So later all this, of course now you take one from the power supply, then all the COM will share, right? Because 1, 2, 3, 4. This 4 COM need to connect later because we will be using 0, 1, 2, 3, 4, 5. All these 4 COM need to connect. So for that COM, you can take this. This cable.
Okay.
Later.
Okay. I do first.
Can
You
do
understand?
first. You try first. Always.
Hey, why? Yeah, I don't know.
No, don't do it. Because whenever before I power up, I will always check first. So no need to worry.
So yeah, the one that is supposed time.
Oh.
I'm not sure correct or not, but just try.
Never mind, never mind. Try first.
I think confused what income and com. Sorry, bro.
This com, right?
Yeah.
This is the at the PLC.
Okay. The other one
The
income.
PLC input, okay? And the PLC on top, right?
Uh-huh.
The PLC input. You can see the com?
Yes.
Okay. So this com is the com for the input. So to decide whether my input must be 24 volt or 0 volt. Okay? This com is the common for my switches.
Okay.
There's two things. One is the input, one is the switch. So both must be opposite.
Opposite.
If this com is 0, the input com must be 24. Okay. Okay, you want to connect what? 24. Okay. Yes. Connect 24. We do only one button first, then we see. Yeah, that's it.
Okay.
So, yeah. This one is 24.
This
So
was
here, this one is the 0. Okay? Okay, good. 0 volt. And this is 24. And this one is going where? Going to the input com. So you connect what?
Input com.
It's a 24 volt.
Yes,
24 volt. Okay. If input com is 24 volt,
Yeah.
then this com must be what?
24.
No.
This one to be 24.
If the input com is 25, yeah. You see here, if the input com is 24, means the switch com lah, right? 24, and this com is must be what?
So you compare 24. This
No.
one's supposed to be negative
0 volt, right?
0.
Okay, means this one must be 0 volt.
0.
Okay?
So device.
Okay, wait, what I do? This one is actually what? The input. Okay, I will connect. Put it there. This output we don't connect first. Okay, not first,
Okay.
output on it. Because I haven't do output wiring yet. Now,
Okay.
let's see.
Because
So,
now I refer to the plus minus this one, okay lah.
just plus minus okay. Now, first, we design input com is what?
Input com.
I mean, this don't confuse. This is the called input com.
Input com.
This is my switch com actually. But just I put in for the input lah, the switches, right? Okay. So this com is connected where? 24.
This one is the switch.
For the switch, yes.
For the switch only.
Yes.
This one is the indicator.
No, not this. This, the loop cable for the switch, and all these are the switches.
Switches.
Yes. This one is the loop cable for my output and all these other line.
Okay.
Now, so this one we connect where? 24.
24.
Correct or not?
This one is 24 now.
24, right? Okay. If this one is 24, this one must be 0.
Yes.
Right. So this one must be 0.
This one must be 0.
Yes. Okay, power up and test. I should move. Now, this one is the power. Okay. Okay. We haven't connect.
Yes.
1 to 0, 0, 1. Good. You see how it works? Very, very simple. You see, I give 0 volt at the top. Okay? Then I take 24. Sorry. Yes, 24 volt, right?
This 24 volt.
Okay. 24 volt, I connect to the com.
24 volt connect to the com.
Okay?
24 volt connect to the com. Correct.
Okay.
Okay.
Then if I take the 0 volt and I connect, I touch to any input, can you see? Any input. I just direct. Okay? Of course we cannot do it direct. So what I did is I take 10 volt and connect here. It means the 0 volt will go and supply to all this. Then one by one I go back. If the com, okay, I change it here. If the com, I connect to 0 volt now, okay? See here, I connect to 0. If this com is 0, my input must be 24 volt, right? But my input is a 0 volt, right? So nothing, because 0 is 0. So what I do this one now, connect to 24. Must be opposite. It's very simple.
Then we can use that.
Okay. See.
Because I refer to your diagram.
Yes. Yeah.
This one to the com.
No, this com is going where?
Now the com is going to negative.
So means this one lah, right?
Yeah.
This com go to the negative. So it means the switch com must be 24.
Swiss com must be 24.
Yes.
Okay.
Means it's a PLD. If you want NPN, you just play with this. You just change this com and this com. That's opposite.
Swisscom considered Swiss ground, right?
Yeah, okay. Okay. Power off. Then you can find all the other values. Yeah, you can just play. Let's change. What do you means you want to use the NPN now? NPN.
is a positive. The 1, 2, 3, 4, 5 is actually positive also, right? Oh, huh?
Which one? Okay,
Top.
which com?
The top
This com.
input, yeah,
Okay, if this com you connect positive,
yes. So and the switches,
the 0, 1, all
yeah, it will be
Zero.
positive one. It will be positive one.
0 volt.
Huh? Oh my god.
You still confused?
No, I'm not confused.
Hmm.
They suck. Now good.
No, I know. The one. The thing is, you understand the concept first. The concept is very simple.
Okay, come here.
Comment 0
Yeah.
always must be positive, negative.
Yeah. I'm not sure if this is correct.
That one, let me see. You
Okay.
see here, comment 0 always must be a positive, negative.
Yeah.
Okay, always positive.
Mm.
If com is 24, the 0 must be negative.
Mm.
Okay, don't see that. Okay, very simple. You see, yeah. If com is 0 volt,
Yes.
this one must be 24, right? The one you understand?
Yep.
Okay. If com is 24, this one must be 0 volt.
0.
Yeah.
Okay.
Cannot be both same. Because inside I have a lamp. You just think as a lamp. Lamp must be positive, negative. Cannot be negative, negative, positive. So if this one 24, 0. If this one 0, it's 24. Now this is 0. This one must be 24, 24, 24, 24. So loop into 10. So this one 0. If this one is 24, the input must be 0. Yes. So if I have multiple inputs, for all the input, the common for the input must be
Then jalan ya.
So who decide that this one okay? This one is just direct. This one you don't need to care.
This one correct, right?
This one is okay.
For example, this one is
This one is okay.
this one is positive, this one is positive. This one is a switch, right?
This one is going to switch. Okay, this one you don't care. This one just direct only, right?
Yeah.
From the terminal to the switch.
So what I mean is, this one is positive. This one also positive, right?
No.
This one.
No. How can it be positive?
Okay.
Yes. Okay. There's no. Okay. Very simple. This com is 0 means this one is 24 positive.
This one
We don't care about this. Just see here.
Okay.
So if the com is 0,
Positive now. Positive.
Positive?
Okay.
and this one must be negative.
Okay.
If this one is negative, this one must be positive.
Okay.
Always must be opposite way. Okay. Now this one is connected to where?
Positive.
Positive. It means my input must be negative.
This one negative.
Okay. All this must be a negative. So how to give negative to here? Through the switches. So I have 6 switches. So all the switch must be connected, right? I connected that cable to here. Okay, this is the cable I connected to the loop.
Correct.
So I connect to 0.
Correct.
Correct. So that's why I say this one we don't care.
Oh,
This one is just 1 to 1 only.
Okay.
There's no power here. And if I didn't give power here, these guys won't get power. Okay. So 0, 1, 2, 3, 4. See, if I take out this wiring, these guys won't get any power. Nothing. So means there's nothing here. It's just 1 to 1. But who gives the signal to this?
But I don't give the power here. Where the power? I only give the ground for this one. But how about power to this?
There's no need to power.
Only power.
Only power.
Okay, this one.
So there's no power here. Okay, that's why I say the term you use ground, you forget about the ground. I know in the industry normally they use 0 as a ground, right? You forget about the ground. We just talk about 24 0 or plus minus.
24 June.
Plus minus, yes, that's all. Okay? Because in industry that sometimes they say 24 means is a power, 0 means is nothing. No, no such thing. Because if you see, if you want to power up something, you need to get positive and negative. If you only give positive only, you won't power up.
Yes, correct.
When they use ground, when they put positive, the negative they go to the ground. From the ground they connect back to that. That's why they call ground. But actually it's not a ground. It's a 0 volt. There's a potential difference. Okay? So if these guys, of course the switches won't it's like just a switch only. It just pass by the signal. Whatever the signal can be 24 volt, can be 0 volt. But currently the common I'm using 24 volt, so the signal that pass by my switches must be 0 volt. Just positive.
But surprised I didn't give the any positive to this. I only connect this to the ground. So how about this one will be power?
Okay, good question. At the com you connect what?
At the com I connect to power.
No power.
Yeah, sorry. At the com I to 24.
24 volt. Okay. For these switches you connect what?
I connect to
No, this yeah,
ground.
connect here, right?
Ground.
Okay, let's say that the 0 volt is the ground.
Yeah. Oh no, sorry. You.
I mean ground also okay, no problem. Okay.
Now I do.
Okay, 0, right? Okay. So to on the input,
Yeah.
what I need?
Do all the input. See now.
Yeah, the one you forget about this. To on the input we need 2 things. One is the com, one is the input. Both must be opposite.
Com and input.
Yes. So because one com is connected to 4 on. So if the com is 24 volt, my input must be 0 volt. Yes. Very simple. You see?
Okay. Actually, required to connect all this together.
Yeah. Then only you can use all these switches. Okay, good. Okay, now this is 0 volt, right? I know you're confused here with this part. Now, how these guys get the 0 volt? There's nothing here. Because this one is not connected to power supply.
Correct.
Right? Connected to here.
Yeah.
From here, it's connected to the switch. The switch, loop.
Yeah.
The loop connected to here. So very simple, you see.
Oh, automatically this one is a plus, this one already minus.
Yes. This minus from where he get?
Okay.
This one.
Okay.
Just need to look what? Because you see why? Very simple. Just negative, huh? Just connect 0 volt. But of course I cannot directly connect. So if I have only one switch, right? So I take 0 volt, go to the switch, from the switch I connect it. Since I have a multiple switch, that's why actually 0 volt I do to on. But I put additional terminal blocks here, so which is easier to do the connections.
Okay. Because I confused about this input. This one is the plus, this one is the 0. This is the ground, and then because this one considered as switch, this one
Already connected to the ground, yes.
Okay, got it now. Okay. Plus, so same to the output.
Okay, then later we just connect back all these cables.
Okay.
Can I erase this?
Yes.
Can I take picture here?
Take picture.
No. Can I erase this? You want to take picture? You can take picture.
Yeah, correct.
Now the output. Now the output, our output is a relay type, right?
Output is a delay time, correct?
Okay, so the output also have a COM. 0, 1, 2, 3. Okay, good. And you have multiple COMs, right?
Yeah.
Okay, all the COM you look later. Okay, all the COMs you look. The first 4 COMs.
Let's say for example, when I put the wiring, all this, if let's say you touch the cable here, it will be short.
You give you power on.
Yeah.
If you didn't touch the negative, positive, it's still okay.
Okay, like,
Okay.
go with that.
Because unless you don't touch the positive negative, because if you touch the positive negative, what happens? It will damage your power supply.
So now you believe me, I'm very beginner.
No, the thing is, it's not a beginner. You can understand.
Yeah,
You know why?
I understand first.
No, you know why? You used to listen to these terms. They say ground, they won't say zero, right? So when I say zero, you get confused. What is ground? What is zero? Because in industry the language is different. They use, because you know when they use ground, actually they supposed not to use the term
Power
ground.
supply.
When supposed not to use the term ground actually. If the zero is connected to ground, then the zero is grounded. So then you can tell the zero is grounded. If the zero is not grounded, it's a 0 volt. It's not a grounded. Because normally what do you do? Okay. And then see, I measure this one. Okay? Yeah, this. So you see, I got it, 24, 0 volt, okay, I get what? 24 BTC. 24, you see, I got it, 0 and ground. Nothing. Right. No, it's in millivolts. Okay, nothing. I touch the ground, this is the ground example, the ground. Nothing. If the 0 volt is connected to the ground, and there's a ground also they connect, then if I press, yes, then I press, touch here and I click here, I should get 24.
It's correct.
It's connected. Or I touch this one, then I touch the ground. Because sometimes the neutral also they connect to the ground. Because you know why? This one all to avoid the noise. For that only they do this. Okay, good. Okay. Now we see the output.
Yeah, because the industry they always connect to a certain, because sometimes they're quite sensitive of electromagnetic.
Yes,
So that's
for
why
that, yes,
they
they.
connect with your table.
Yes.
Is that so serious?
Yeah, because you know why? Because it's always passing by the voltage, right?
Yeah.
So it will, sometimes here also sometimes if you touch this one, right, you can get the static current. Because always we work on the cables, or so always the positive negative lah. So that's why on discharge they will connect this. When last time my brother's company, he said this one is like a box. So they have like the air gun, not air gun. They will it's a sand gun. You know the sand gun. They will with the high, very spare, there will be a sense to clean some what metals everything. So what happened? The machine you put inside there is a glove, you know. Actually, it's a glove. The glove. Then you touch the gun. Then you send your the pipe, okay, some metal pipes, okay. So sometimes from the when you go to the table or something, right? It's actually a glove. Sometimes you can get a spark, you know, because of the static. Because why? Why static? Because the day you told me that what happened is they go and the ground, they go and connect to the table to discharge the static. Then now okay. Even glove, you know.
Gloves also.
Glove, yeah. Because why? At the glove there's some ions moving, right? Then your table is because you are the gun is it will throw the sands. So this here also will charge something. So when it's opposite plus minus, of course some spark.
How about they put on the table, then will be okay with it. Is that because they connect to the ground?
Yeah, something like that. They just do something, and also they reduce. There's something they say there's some rubber or something on the table. Okay, they reduce that one. That is okay. Okay, now the output. You see, output also the same concept. Power supply. Okay, we take one connect here. So how the output work really, right? So it's like a switch inside. Okay, it's like a contact inside the PLC. Okay. This one is inside the PLC, now, so it means whatever you connect here, that will be my output. Okay, that is going to the lamp one by one. Lamp, relay, contactor are same. Then the other side must be loop connected to a terminal block. That is the output COM. Okay, then go to the power supply. Same concept as an interval. You see, if this one 230 AC, because it's a delay, right? AC means when AC go in and stand by here. When the output on, then the AC go on. So then this side must be what? Neutral. Okay? If let's say I supply 24 volt DC, then here will be the 24, here must be the 0. So 0. Let's say this is the 0 volt DC. Connect here, then this one must be 24. Same thing. So you see, this is the PLC COM and my LAN COM. So the PLC COM and the LAN COM always opposite. Cannot be the same.
PLC COM and LAN COM also different.
Always same. Always the opposite. Same like the PLC input. Input also, the input COM and the switch COM always the opposite way.
Then will be negative.
So it's up to you. So for this lamp is a 24 DC lamp. So you can use the DC voltages. Of course AC cannot use. So you take one, connect to the COM. Can be positive, can be 0. It's up to you.
Because just now I didn't connect this one.
No,
Not related.
Not related.
Okay.
Not related. So it depends on your device. What is your instrument you're using? Let's say for these instruments I need to give a 24 volt. Then the common must be 24. It's depend on the same like the switches, right? You depend on the NPN, PNP, right? Same for my output. My output also is depend on the what signal you need to give to the
So
source.
for example, my switch now is NPN.
Yeah, the switches now is NPN.
Switches now is NPN. So signal in to be ground.
No, for which one? You are talking
Let's
about
say
the input or output?
Output.
Output.
Output
Okay.
NPN. That's it.
Output you want to use NPN. Normally output they don't use this term NPN, PNP.
Oh, then maybe.
Normally they will call about, if let's say it's a DC output, they will tell like a sync output or source output. They don't use the term NPN, PNP.
So sim will be
Zero.
Source will be 24 maybe. So I will use it. So this switch is what sim or
Both
source?
also can.
Also can.
The lamp is just opposite way. 24 also can, 0 also can. It depends on you. So you just fix one, then you can do the work. Is it power off already? Wait a moment.
So meaning that the income just now I use the income I use as a 0.
Yes.
And outcome I also can use 0.
Yes, can.
Alright.
Yeah.
So it depends on if let's say 0. So my that one my com will be positive.
Yes, correct.
Like that. I thought income and outcome is supposed to be opposite.
No,
Ah,
not necessary.
I get now. That's why I always confused in my theory. Okay. Interesting. But always need to have a diagram before do the wiring.
Yeah, because
Otherwise we'll be confused.
Of course, because panel wiring is different. Because panel wiring, normally these will be another page, these will be another page. So this one will be the power supply page. So there will be a power supply, from the power supply go to the terminal blocks until there only. From the terminal block, from each one terminal block, I'm going to the COM, everything will be another page. So that's why I say, like I said, those who do wiring, connect wiring, they don't necessarily to know this NPN, no need to programming, of course, no need to program. The NPN, PNP, all they don't need to know because no need to know. Because they already in the wiring diagram, they already put everything there. Okay, this is the terminal block, because in the wiring diagram, they won't mention is that NPN or PNP, whether it's a source or sink. No, it just mention, okay, this terminal block, okay, what number? This cable from this terminal block to this terminal block, okay, what is the number? They just tell you the number.
Then how the wiring guys when do the wiring, they connect this to big kaki. Later you connect different NPN, the kaki different, then jump.
That's the thing. Must do a proper wiring diagram.
Yeah.
So the wiring diagram must be correct.
But the one who designed the wiring diagram, they need to know which kaki, right?
Yeah, of course. That information you need to give to those who design the wiring diagram.
Okay, another question.
Yes.
All this kind of a person who design all this machine and wiring, so they need to know what machine, what components, everything.
What machine?
What machine, what is to be connected together with wiring. He need to know everything. Or just in terms of general masterpiece, then only go deep into
Okay, very simple.
wiring.
The guy who design wiring diagram, okay, what the things he know, right? So you need to know. If you ask me lah, you need to know. Of course, you need to know the basic wiring and everything. Okay. So you need to know what PLC you're using. Okay, what PLC. Okay. Then what sensors are you using? So from the sensor, I know whether it's a PNP or NP. Then only, because this 3 wire color, right? Then only I know 24, 0 volt, and this one go back. Go to the black color, go to your input. So when it go to input, then of course they need to tell the wiring diagram, and the COM you need to connect what? You need to give the data to the wiring diagram, and the COM I need to connect what? 0 volt or 24 volt. So you need to tell them. Then let's say a special instrument. So in the special instrument, okay, how many terminals there? Let's say 4 terminals. So you need to tell the guy, terminal 1 is go back, power supply. Terminal 2 power supply. Terminal 3 go to the input. Terminal 4 go to the output. All this you need to tell.
Oh, so you must be very mastermind.
Yeah, need to know most of the things. So very nice. But of course, like before you go to that, you need to what? You need to feed them with the proper necessaries.
Yeah, but I really wonder what kind of equipment you're going to use, what kind of cable you're going to use. Yeah, it's not easy at all.
Yeah.
Huh? Sure, I will become one of them. I want to become
One of them.
but this one maybe take a lot of time to practice.
Yeah, of course.
I think that will be much easier for you, right? Instead of you do education.
Which one?
Since you do the teaching now, I think all those kind of program is much easier for you. You prefer education instead of
No, I prefer to hands-on instead of teaching.
no.
Because teaching, because it's just teaching the basics, right? All these are basics only. So when you do programming, then only you can able to go inside, explore more. That's why sometimes I do some small projects.
Yeah.
Yeah.
I have a lot of drawing and I look at my team drawing. Wow, so comprehensive.
Yes.
Especially from the client side. Wow.
Chef.
It's a chef. How come?
I don't know. You want to learn PLC?
Chef, huh?
Yeah.
This chef, unless depends on the background. Let's say his background engineering or
No, his background is culinary arts. I also don't know.
then why is it purpose? I don't understand why you need to learn because it's very complicated.
It's totally
Totally
different.
It's totally different.
Totally different. At least he got an engineering background. Any engineering background. Actually, PLC is suitable for any engineering background. Electrical, electronic, mechanical, mechatronic. Even sometimes I have participants from chemical engineering.
Like what I think, like how I say, you want to learn, yes, you can free to learn, but this, you don't have any practice ground. You learn just like previously, I learned just like for the knowledge, but until now I still not really hands on because I just get the basic, but not practice. At the end, I still forgot the theory.
Forgot.
I
It's
forgot.
no, it's not a cheap. So
It's not cheap. So now I really hands on. No, I see the people hand. I see my team is hand on. I want to get involved. So then I will hands on look at the program, how to troubleshoot. You got place to troubleshoot, and then see
you
what the program.
have things to learn. You have the place. Then because you say your team can do programming, right?
Yeah.
So if you do something, they can guide you.
Yeah.
Then you know what question to ask.
Yeah.
If any problem, okay, let's say like now you're troubleshooting. So something you see. So you call them, they say, okay, oh this one, okay, you change the timer value. You change this input. Now you open the normally to something. So you know how to do it.
Yes.
Just like the same thing I tell the other guy. Actually, most of the participants they come for this only. Because sometimes a small issue, you need to call the vendor to come. Then they come and charge high.
Yes.
So the small things, changing the wiring. Sometimes you know what happens.
Not chips.
Sometimes one of the output is burnt.
Yeah.
So you need to take out this wire, connect to the available one. If you do this, of course in the program you need to change. This one very simple to do, but in the program you don't know how to change. You call them to come. So when they come, of course they won't charge like 100, 200. Right. Just change only one. They will charge everything. The transport everything.
Yeah. Because sometimes your company, this project belong to previous PLC. You don't have a team to support. You also need to outsource your support.
Yes, outsource. So you connect this one to the 0, right?
Yeah.
This come to 0. So it means this one the positive.
This one I haven't connected.
Yeah.
This one I haven't connected.
Go to positive.
Yes, this one.
Then
So this
0, 1, 2, 3, 4, 5. Yes. You use a small figure?
Now I understood now. At least I know that the input and output you can be
Can
different.
be different, yes. I know because sometimes
Because I thought input like that.
same question.
And input output should be like that now. Alright? Because if this one positive negative like that, this one.
You know what? You know why?
That's why I cannot cover there.
No, same thing. For other, most of the participants they will confuse on this part also. They say they thought, oh, input and output can be different. I say, of course can be different. You know why? When you let's say for example, you don't know about this wiring, for example, suddenly got problem. Some vendor come and check. You ask the vendor, hey, this one must be 24, this one can be 0, right? So do you think he got the time to teach? Just yes, it's 0. Then sometimes they say, oh cannot same, cannot be same. Or they say input output must be same. They don't have the time to explain you. That's why actually because most of my participants they always think the input and the output must be the same. If input is positive, output also must be positive. Input is negative, output is negative. I say no, not necessary.
That's not like holding the ground or something. Correct. Okay. Okay.
is not here because this program just now you download to here.
Yeah.
We haven't downloaded here yet. Okay. So one lamp is working means because it's from the previous project inside, right? So it means the wiring is correct. Okay. So actually they're supposed to have one, so today I take it for one project. Now, work online. Transfer, yes. Download to PLC. So I think can. Yes. 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 Okay, good. Yeah.
Only the first one.
Only the first one, the first program we have. Any question?
No.
So far, yeah. So I mean, for the wiring also, if you want to learn wiring also, just buy one PLC like this, you know. Just buy a small switches. You need to buy like this switch. You know, that these switches are not just the toggle switch, the small one, open and on and off the toggle. I want also can. I want do some wiring, just practice okay. Positive negative. If I put positive, both positive one and both negative one cannot work. Both negative cannot work. Both positive cannot work. If I put one positive, negative can work. Then we decide okay whether it's a PNP or NPN or negative. That's how actually how I also learn. Even because when I come here, I know electrical, positive, negative, all these. But when I do the first panel, I don't have experience on it. I just follow my boss.
Yeah, first panel after this is my first panel.
First panel, I just follow okay, my boss say okay, this one, this one, this one. Once I do a few panels, then only I understand okay. This is the reason we are using at the COM is 0 volt. Why at the COM 0 volt? Because my sensors are PNP. So the COM must be 0. Then only I understand. Then to relay how to. Okay, so we take the break. And after the break,
I will stay here. I stay here
okay.
for digest. mentioned the switch is PNP, NPN.
Can be NPN, can be PNP.
Oh, okay. But I only see you connect two cable only.
Yeah. Cable
PM, I thought
it can be NPN or PNP.
yeah.
Both can.
They need three cable, right?
3 cable only is fixed. NPN or PNP. That's it. I give you the sentences.
Did you mention it?
No, no, no. These are the NPN or PNP sensors. Look at this. Thank you. So how to know NPN or PNP is the part number. You need to check the part number. The Google, they will give you the NPN or PNP.
Black one is also the signal.
That is going to the input. This two is the one going to the power supply.
Power supply.
Yes.
Power supply here.
Yes.
So it's going to be
Input, yes.
because the common ground is already we define
Yeah.
first.
Yeah, it's common, we already defined
We
it.
already define.
Okay, let's say for example, we test this.
And this one also ground also
Output we don't
define.
care. Yeah, output nothing. Output we don't care.
Output we don't have.
Output is not NPN or PNP. It's a source or sink.
Oh, output always was a source of signal.
Source or sink.
But still NPN and PNP, right? Source of signal.
Yeah, it's still an NPN, PNP, but normally they won't call NPN or PNP.
Source
Now,
means that will be a
positive signal.
signal. But the common will be negative.
Yes, correct.
Uh,
It's the same concept as PNP, NPN, but they don't use the term PNP, NPN. Then you'll be confused.
Now I know Siemens source is used for output. And PNP is using for the signal that
Yes.
receive the input.
Yes, correct.
Oh, thank you so much. You clear. But sometimes I also confuse with Siemens.
Yes, yes, yes. Okay, you see.
This one is signal. Because you keep disturb the staff, asking them, they also ignore you.
Yeah, that's right. These questions, if you ask the
Too much,
if you ask the guy who come and install, can he tell you one time? But if you still not understand, they won't do. You see, G6 GTE P122 is a PNP sensor. PNP sensor. Okay. So now you see, now our connection is what? NPN and PNP.
This one is the to positive.
Positive. So means our signal is a PNP signal.
Positive. So positive.
Positive means
Then this one
minus.
is negative.
Yes.
Negative is NPN.
NPN. That's correct. Correct. Okay. So this one can use. We try. What we do?
This one PNP.
Bring one terminal block.
If we have wire.
No, you won't get the signal. That's all. Just put one card. One card.
Clear my mind.
Just put one card. Easy to because cable not too long. So first this one is negative, so I can connect here. Then the signal go to the input lah. Cable one now. because this is a PNP sensor. Okay. So this one is what?
But let's say this one connect to the output cannot, right? Can.
Yes, so this is the input.
Let's say cannot connect to the output.
Cannot connect the output.
Cannot.
Won't work. This one CR
This one is.
no, it's not showing. Number 6.
The problem is why YouTube put all this kind of different people talking different things. That's why sometimes a lot of confusion.
Yes, because they won't.
They won't talk the right thing. They have their own kind of sharing.
Yes, they won't
Then
kind of
we
explanation.
try to absorb the wrong thing. Then different person will talk like this. Oh shit. The double.
Yes. Here we do put NPN. Oh, it's a NPN. This one is a NPN. Then this one should work. Okay. So even the NPN, PNP also when you go Google and YouTube and they have different type of this one. That's why always have these confusions.
It's just normal contender.
Yeah. This one. Let's again.
Yeah, the detector.
This is enough access. So if you buy a wrong PNP or finish. But if let's say if you want to use this how
The right idea is you just
because this switch no problem. Is it the NPN or PNP? So I just change this COM and I just change this into COM. Make it NPNB lah. Can go. If let's say one is PNP, you already fixed everything PNP. Now you buy one wrong one, but still want to use now. Use a relay. Relay can use as a switch, right? Because so this signal go to the relay coil to activate the relay coil. Then the relay can give 0 volt. Because I have done this before.
Okay.
Because one time when I buy a wrong sensor, so need to order the sensor will take I think 3 weeks. Then just put one relay.
Small relay.
It's a small one contact relay. Okay, good.
Okay.
Okay, good. So now we go offline. Okay, so I start motor on right. I add another one. You put normally open here T0.
T0.
Yes.
T0 is Hakko.
Yeah.
Correct.
Yes.
Okay.
Okay. Then you add output here 100.01. it's here, right? Okay, what you do, just click the, sorry, you click here, drag until that, yes. Then you join this line. Then you latch it. Then, yes. Then you add a stop button here.
Same point 01.
Same. Okay. Okay. So what happened? I start motor on, right? When the motor on, I on a timer. After the timer, the same timer I use here to off the motor one. Another timer to motor two. Okay?
Okay, the third one, motor two.
Yeah, change this name to motor two.
Motor two.
You put escape. Yeah, ready? Enter. Motor two. Okay. Save online download. Start. Okay. First one on, then second one. Stop. Second button. Is the stop. Okay, the first button is the start, second button is the stop. Okay. So can you try to add one timer for motor 2?
Timer for motor two.
Yes.
This one I need to change.
Okay, now you press. After the timer, use the T0 to cut off it. Normally close T0. Sorry, T1. Here. because you see, this timer will on the motor, and this timer I want to off the motor. Yes. Okay, good. Any question? Close this. Close this. Okay. Now, you see, whatever we add here, right? The timer, the stop, everything will be added in the symbols. Go to symbols. Add any symbols. Okay? Under the comment, there is no name. Okay? Actually, you can add here also. Okay? Let's say first is the start button, second is stop button. Let's say third button is the sensor. For example, the third push button is a sensor. You want to add here also can. You right click here. Right click, yeah. Right, you click, right click, yes. Insert symbol. Okay, why I don't add here? If I have to add here, I need to add the name. Okay, why I don't add name? Okay, I will tell you. You put sensor. Okay. Then add address 0.02. Okay. Added up. Let's say go back to the section. You just add here the normally close 0.02. Okay. No need to comment because you already put the name already, right? Okay. You see what? It will what?
Sensor.
It will show only sensor. It won't show the address. That's why I don't like to use the name. I like to use the comment. But you can know the address because normally in machines they use the name. Okay, the machine they use the name. Okay, you go to this. You click here. When you click, you can know the address here. What is the address? But here it won't show. Here it would only show name or address. If you have a name, it will show name. If you don't have the name, it will show address. Below it will show the comment. So that's why normally I will add here the addresses. I don't add in the symbols. Okay? Okay. Just continue. Yes. Okay. Now, what is the function of? Now we just using the I mean the channel 0 and channel 1, channel 100. Okay, all the channels are there. Okay, what is the function of holding memory? H. Okay, for an example, but I don't have a battery for this. go to settings. Go to the hardware settings. Here. You see here. Settings. Okay. First, startup data rate. Okay. Clear retained memory. So when I start up lah, okay, retained memory value become irregular when running without battery. It means the value of H, value of B, value of the counter become irregular. Okay? Means it just the value all lari lah. Okay? Why? Okay, close. Because no battery, right? Okay. Earlier no battery, now we add battery. Okay. So it means the value go to PLC, work online. Yes. You go and check the memory. Okay. Go to memory. Go to D. Make it bigger. You click monitor. This and this. Monitor. You see? All got some values. Do you think my previous participant want to use all these data registers? No, right? But why become this? Because no battery. Okay, earlier no battery. That's why it become like this. If I put battery, then this value will stay according to what is my set point earlier. Okay? What we do? We close. We can clear
This one is previous memory. No, previous holding.
No. What happened is, okay, normally every training I will use the data register lah, right? But I don't use all the 8,000 data registers.
Correct.
I will just use the maximum 10 data register.
Yeah.
Okay. But why others all become irregular like this? Because this PLC don't have battery. So when I power off, but it won't be immediate lah. After some time, the value all become irregular.
But because this one before no battery, it's not supposed to be hold any data inside there, right?
No.
It's still store. It's still there, and it still store the data inside the PLC. The data
Okay.
still store.
The logic, yes, it is not. But the values, because the D area will keep values, so it won't store the values.
But it keep value. But how come it's already full?
Yeah, it will all the values. It means become what it's telling is it won't make it zero. It won't make it zero. It just become random values. I know what you mean. Why some value that's supposed to be zero, right? No, it won't be all different values. Okay, I can clear all this. Okay, close. Don't need to change. No. Okay, go to right click the PLC here. Operating mode, program mode. Yes. Program mode means it's a stop mode. Stop program. Okay. Go to PLC. Clear all memory area. Okay. This one means I clear everything. All the program, memory, everything. Okay. Initialize. So I clear what? I clear the program area, I clear the parameter, PLC setting, everything lah. Okay? Clear. Okay. Yeah. Okay. So I need to down. If you press start now, you press start, it won't work. Press start. I know. Before that, you right click here. Operating mode, run mode.
Okay. Why not you use a PLC stop?
What PLC stop?
You need the PLC work offline.
No, that is this work online, work offline is a connection between your laptop and the PLC. It's not like stop and run the PLC. This is the stop and run the PLC. Okay, now you press start. Can you see? Not working, right? You know why? Because it clear away, right? All the program is lost. Need to transfer again. Okay, transfer. by default settings. Yes. Okay, close. Okay, now go to memory, go to D, go to monitor. Now become 0. So if the battery is still there, I off, I leave it for a few days, then I open also, still will be 0.
If the battery off, if the battery off, if the battery take off,
You mean what? Battery take out?
battery still remain there or?
Battery still remain there, so the value always will be 0. Then if let's say I use this number, I put some value here, so the value always stay there. It won't change unless I take out the battery, I power off, I leave it for a few days, then I open again, then all the value become irrelevant. It won't go to 0. I know what you think. Why not going to 0? Because that's how the format.
So even we have a data running, if you don't store any data, it's supposed to store data, right?
Supposed to store, but we haven't used any data register. We haven't used any data register, so it won't store it. Unless we use some data register, then only you can store the values. Okay, good. That is data register. Okay, go to setting again. You see some other settings. Okay, so if I use this one, clear, it means
Clear everything.
every time I power on, it will clear. Okay. Then startup mode means when I power on, what you want to use, you want the PLC go to program mode, monitor or run mode. This is the on and power on. Okay. Okay, this one is a process that means stop the CPU if there's an error. If the detect low battery, stop everything up. Okay. Go to timing. Timing is the watch cycle time. Means okay, PLC have a cycle time. Means okay, like from, let's say you have 10 rounds. To read the 10 rounds, it will have a time to read. So normally it will be like milliseconds, 1 millisecond, bigger than 1 milliseconds. Okay, so that's how the PLC will work. Means from left to right. Means how the PLC work is from left to right and top to bottom. That's how the PLC will scan the program.
Left to right.
Top to bottom. Yes. Once finish here, then only go back. That's how the PLC work. So that is the timing here. Okay, input constant. Okay. Input constant, it means that it depends on the, how to say. This one is the time the CPU take to read your, once you give the voltage, NPN or PNPN. So the CPU will take 8 milliseconds to become 1 or 0. So you can reduce that or you can increase that. But normally you don't need to do it unless you are using high speed counter functions. High speed counter means you need to use an encoder. You know encoder, right? Encoder, because encoder, like I said, just now we discussed about transistor output. Transistor output we use in the servo motor, right? Because to give pulse, high speed pulse. So relay cannot do that. Same concept in the input side. For the input side, we what is that? We call it's a high speed counter. So when you are using encoder, then you must use high speed counter. Then you need to enable this timing here. Okay. Next, go to building. This one is the setting for your RS2324.
RS2334. RS2334.
Port. Okay. Then
This one usually not required.
no, this one is just custom lah, standard lah. Okay. Let's say for example, you are using HMI. So the HMI should work in the 96172 in this format lah. This is the baud rate, everything. Let's say the HMI cannot support this. The HMI only can support 19,200. Then I have to change custom. The HMI can support this, I follow this. So it's depend on the device I connect. Okay. Serial option. This one same thing, but if you are using option board, using the option board, say RS22 option board. Okay, same setting. Yes, this one. Just now I take out okay, building input. Yes, just now we talk about the input constant, right? So when we do the setting for this one, 1 millisecond or something, then here is the high speed counter. So this PLC can use 6 high speed counters. So if you're using encoder, you want to read the rotation, because normally encoder you can read the rotation, right? So you must enable this. Okay. Next, the other two is the pulse output. So like I said, if you're using a servo motor or stepper motor, this is where you need to enable all the functions. Okay, but now this PLC can use because it's the relay type. Because my software don't know whether it's a relay type or transistor. My software only know how many I/O. So if you want to use this, then we must know whether which transistor want to buy. Okay, can? So these are the settings. Okay, close.
Normally all this one no need to change, right?
No need to change.
Certain
This one no need to change.
certain
But
need to disturb only.
now, normally the building input, the pulse only we do some modification.
Which one?
This one here and the building input. If you're using high speed encoder, then you need to do setting. Then if you're using pulse, then you need to do setting there. Oh, but all the setting in the manual they will tell you what you need to choose using high speed counters.
But even though you're using a high speed counter, how they know you're using this, how to detect the PLC? You need to do any data diagram.
Yeah, of course. Need to do it here. Then, if it is high speed, 0 means so you can use the 0.0 for normal.
0.0.
Yes. Okay, just now, where is it? This one, right? Manual. In the manual, just now, I have this thing. Go up. Go up, this one expansion. No, under, I think, third one. This one is just 2. Third one. High speed counter inputs or normal input. You see that? Channel 0.0 and channel 0.1 is as a high speed. You can use as a high speed counter or normal input. Now we are using normal input, right?
Only for 0.0 and 0.2.
And if this one is can be 0.2 until 0.7 is can be high speed counter inputs, interrupt input, quick response input, or normal input. Okay. So this, and from 0.08 until the 2.11 depend is a normal input. So if you are using, this is the wiring. They show you some wiring here. You can see here also. Okay, you see, yeah? Okay, that's nice. You see the COM one?
Yeah.
What they put? If the COM is negative, the input is positive. Right?
Com here is negative.
You make it bigger? No? Yeah. Okay, yes. Because this is the positive negative symbol, right? If the COM is negative, the input must be positive.
Correct.
They say you can use this or this also. If the COM is positive, the input must be negative. Yes.
Correct.
Yes. So both way can use the NPN. Actually, this is what I know. I draw it.
Correct.
Okay. Okay, go down. I mean, make it smaller. Okay, go down. Next page. Next page. Okay. This one is. Go up. Okay. This one for the output. Right, they say. So they see for output, pulse output, I can use only channel 100 and 101 only. Other channels I can use. Same like the input just now. So they already specify which input, which output need to use.
Okay, this one is output for the device.
Like
the counter.
The servo as the stepper. Servo or stepper. Mostly the pulse they use for servo or stepper.
Let's say I use already this signal, I need to change the signal to the purposely for
Yeah, you must use these two only.
let's say I use already for others,
Mm.
then I have to change that signal back to the servo.
Yes, then the other one I need to change to the other outputs. Same for the input just now. The input also same just now.
Or should we reserve this number always to be empty?
No need.
No need.
Because whenever we design a system, we already know whether you want to use a servo or stepper.
We don't know.
Only we know. So here they put really maximum frequency.
get into more detail of this. So
Yeah, no, just show you lah.
yes, at least I
So at least you know that these PLCs can program for encoders, servo, all that. So later on when you are using that time you can just explore on them.
encoder you mean is as a servo motor, what is that? Encoder.
Okay. Encoder only is different. Servo motor and encoder is different. This is the encoder only. So you connect to the motor encoder. So from here you get the signal, then this signal connect to the PLC. So it's like normal motor running. You want to know what is the speed everything, you can fix that. Okay. Servo motor is something like this. This one, but it's already spoiled. This is the servo motor. This is the servo motor, servo drive. This motor comes with the encoder. So this one is, this encoder is just giving the signal to this drive, not the PLC. So the PLC send the pulse output initial to go through. Yes. So encoder, not to that. So it's an additional encoder. That one is already included with the encoder. So it's already, the encoder always gives the signal to the servo, then I can just read what is the signal and everything. This one is the additional encoder. Let's say the motor don't have encoder. So I want to know what is the speed. All that. If I think if no question, I think you can stop here. Then if too much means then you also confuse what you're studying.
Oh. Hi, okay. So, or you want to download the program first? Or
Which one?
GS only right later, right?
JS works 3, yeah?
Yeah.
Yeah, later.
Later.
Later can install the JS works 3. Okay.
It's the same motor laptop.
Sorry?
Yeah.
Yeah. I find it powerful as well. So I will go back to look and if I
Yeah, you will go back and just try to this one. If you have time, just explore.
Yeah.
And tomorrow when you have a question, you can ask me. Do you have your company programs?
Sorry?
Your company programs, do you have?
Yeah, I have. That's why I try to find out. Wait, I try to find out.
This one okay.
No, download the driver. The HMI driver.
Oh. The HMI driver from the internet or what?
From the internet.
What HMI is this?
No, I only installed the software. The driver for the USB cannot download.
From the USB. That USB cannot lah.
No, that's the thing. The driver cannot.
Okay.
The driver cannot.
So
When you connect, it will show the driver, right? You
Uh-huh.
install the driver.
Uh-huh.
So I cannot download the driver. I just because in why there's other driver. When you install, it's not detecting the label.
No, I find out tomorrow.
Yeah, sure.
Yeah, I think because that is the 3.0 cable
No,
to
not
USB.
because of this one.
You sure? Maybe you need to use the older model USB.
Because that one, the USB is not working. But this HMI, the USB can detect.
Oh, okay.
The seat, what the printer port can detect. But cannot detect the driver. But that one, the other one, the printer port also cannot detect. So once I get the driver ready, and but still, need to copy from there.
This one, right?
Because if you want to copy from here, it's still okay because got Ethernet port.
Okay.
I only any driver, just
But there are no program. That one is a new one, lah. All the program from here.
For Hakko, the one is that the one I'm supposed to the software is only
the one you the TS something.
yeah.
Because every day got a lot of inquiry who was which things.
They proved this also.
Which one? No, it's already good.
You know, last time, you know what? Last time we covered everything, make sure everything look nice. I will still have the picture. What a good thing. everything.
Huh?
No,
During that very
not this one is belongs to one client. Last time this whole back panel is empty, so there was a problem with the PCB inside. So we sent for repair finished already, so it was empty. So we built this thing for them so that can keep it covered and protected. Now this side over here also they break. It's like that. What do you do?
so send for repair now.
No, and no need to send for repair. But now the thing is, Tivian is trying to grab a program from this and upload it to that HMI and this one also. But the problem is he can't able to communicate. He can't able to. It's not detecting. The USB port is not detecting. It's just that we don't know which version driver for the communication is using. So that's. I have to figure that out.
Your time, people has
So you came by car or
my company.
which one? The one. All of it. Okay.
And to drive.
The look whose car I look. Look your car. Oh. I think that one is okay.
Still repeat.
Yeah, it's not like take a painkiller, there's no sleepy, that's why I go get coffee. Because keep on talking, right? That's why.
Yeah.
Keep on moving, right? There's a
Saw near the jaw area.
no, because last time I was saying need to cut out the last one.
There's
still do that too.
Yes,
yeah.
because it's supposed to grow this way, but now mine is growing straight. So I will be seeing everyone.
Oh, they're going on. Mine also saying sometimes it will grow over here.
My wife also not come out yet. It's inside.
Yeah, mine also same inside.
Inside.
So because of this one, normally you say they must grow just like this only, slanting. So mine is growing straight. So when it's straight, now it's little bit come out already. That's why it's been
Not when it come out.
little bit come out already. That's why.
Both don't come out. I say sometimes if you not cover, it's not come out better.
Yeah, because
Come
if it come out, because it will go accumulate all the food inside because the flush will on top. The the teeth like this, right? So whatever you eat, go inside there and stuck.
Yeah. Like
Then-
we eat meat pieces or what, the stuff, and it's not easy to keep it out also. Okay, sir.
Okay,
See you
okay,
tomorrow.
yes. I prepared a lot of questions for you.
Okay.
I'll give you a rest.
Okay.